Distinguished guests, ladies and gentlemen, I am the MC today. My name is Zhao Li. Welcome to the Plastic and the Rubber Industry Trends Forum, online organized by Bureau of Foreign Trade, Ministry of Economic Affairs, and executed by TITRA and Plastics Industry Development Center. Today we'll talk about the three topics of circular economy for plastic and rubber, plastics on the move, and the medical magic by plastics, as to further explore the future development of plastic and the rubber industries. Before we start, let's please welcome the President and CEO of TITRA, Ms. Leonore Lingfang Miao, to give us the welcome remarks.
Hello, everyone. It's a pleasure to see you all here today. On behalf of TITRA, I would like to thank Mr. Guanzhi Li, Deputy Director General of the Bureau of Foreign Trade, Mr. Yao Guixiao, General Manager of Plastic Industry Development Center, and all our distinguished speakers and panelists for being with us today. This year, due to COVID-19, we regret that we are unable to physically host the trade shows, Taipei Plus, ShoeTech Taipei, and the Forum. However, we believe that in the continuing battle against the pandemic, distance will not block human connections or hinder the progress of the industry. Therefore, we have leveraged the latest internet streaming technology, making this event happen as an international and digitalized platform for global professionals to connect and synchronize with the market trends. The plastics and the rubber industry is now facing a highly polarized time. The demand for plastic products such as medical equipment, online shopping packaging, and food delivery packaging has surged since the outbreak of the pandemic. On the other hand, concerns for environmental health is calling for more actions on recycling and carbon emission controls. Plastic and rubber are durable and versatile, but need to be safe and eco-friendly. On top of that, Taiwan manufacturers, same as the plastic and the rubber industry worldwide, are on the path of transformation from automation to Industry 4.0. Manufacturing process and machines not only perform more efficiently and more precisely than ever before, but have also become much more intelligent, power-saving, and tailor-made. In particular, they can be integrated into the client's business plan and generate possible applications in various sectors. The forum is going to unveil both the challenges and the opportunities of the plastic and the rubber industry. So we are pleased to have an all-star lineup of top executives and industry experts from globally well-known companies, including BASF Taiwan, Milliken Asia, LCY Chemical, Living Fountain Plastic Industrial, Zhenxiong, Eternal Materials, Fuqiangxin, and Henkel Taiwan to share their insights and visions. We are also welcoming Plastic Industry Development Center, PIDC, the foremost research and consultant organization in Taiwan, co-founded by the government and the plastics industry to moderate the panel discussion and get the most out of the panelists. You are more than welcome to visit the online exhibition of Taipei Plus and ShoeTech Taipei, which kicked off a few days ago and will last for a month until October 28. With the forum today, we are sure all of you will be enlightened by how the plastic and the rubber industry is striving to make a convenient life and a green tomorrow come true. Again, thanks for streaming with us. Please stay safe and healthy. And we look forward to seeing you next year in Taipei at Taipei Plus and ShoeTech Taipei 2022 from September 27 to October 1st. Thank you.
President and CEO Li. And next, please welcome Deputy Director General of Bureau of Foreign Trade MOEA, Mr. Li Guanzhi, to give us his remarks.
Good morning, distinguished business representatives and industry leaders, friends from media, Ms. Lin, President and CEO of TAITRA, ladies and gentlemen, thank you for joining us today. On behalf of the Bureau of Foreign Trade, Ministry of Economic Affairs, I would like to extend our warmest greetings and welcome you to the online forum of plastic and rubber industry trends. The plastic and rubber industry is one of the important pillars of Taiwan's economic development. In this era of smart manufacturing, automated and unmanned production will be the mainstream in the future. Plastic and rubber machinery manufacture also plays an important role in our industrial upgrading. For the past 50 years, Taiwan's plastic and rubber machinery has been one of the top 5 exports of the country, and they are internationally competitive. In the year of 2020, Taiwan's plastic and rubber machinery export value was almost $900 million, making Taiwan one of the world's top 6 exporters. The total export value of the plastic machinery from January to August this year also reached about 11% increase over the same period last year. The major destinations including the developing and the developed countries of the world. Bureau of Foreign Trade, Ministry of Economic Affairs, continue to assist Taiwan manufacturers in exploring new and emerging markets. I take the African market as an example. The imports of machineries is increasing year by year. Growth rate of imports of plastic and rubber machinery ranks the second among the region's top 20 imports. It's about $1.2 to $1.6 billion per year. This gives our manufacturers a very promising niche to turn their experience and their expertise into business. EU also proposed the imposition of carbon tax to echo the global trend of zero carbon emission. Taiwan's plastic and rubber industries also reducing emissions through the development of smart manufacturing and the enterprise transformation. Taiwan's government also emphasized the importance of this issue and continues to work on it. Taiwan's Industrial Development Bureau, together with Plastic Industry Development Center, implemented the project of innovative applications. This project seeks to develop key technologies and high-value products in the industry of plastic and rubber elastomers and fiber-reinforced composite. It also aims to lead the plastic and the rubber industry to invest in green innovation and link it up with the innovative and the emerging industry plan. Now, we are gradually applying this to transportation, medical products, and many more sectors. In addition, the intelligent cloud platform for the machinery industry, jointly developed by the Ministry of Economic Affairs and the private sectors, is set to be completed very soon this year. It includes 5 major functional modules for the plastic and the rubber industry, covering machine management, quality analysis to meet demands from the industries. Today's Plastic and the Rubber Industry Trend Forum also includes some important keynote talks. They will discuss 3 popular topics of the industry: circular economy for plastic and rubber, innovative applications in transportation and in the medical care. The demand for precision injection molding machines and the extrusion machines in particular will be soaring in the coming 5G era. Plastic and rubber are everywhere in our daily lives. The transformation and the upgrading of the plastic and the rubber industry is also reflected in cross-sector and diversified applications. New and composite materials can be used in a wide variety of new fields, such as aerospace, automotive, communication electronics, precision medical products, and so on. The innovation and the improvement of the materials and the manufacturing processes also paved the way to sustainability evaluation. The Ministry of Economic Affairs Taiwan has continued to accelerate the promotion of the smart machinery industry to achieve two goals: making the industry intelligent and turning smart machines into a large-scale industry. Today's forum is dedicated to industry experts from around the world and from Taiwan's plastic and rubber industries. They have all come together to share their experiences and explore more new business potentials and technologies. Taiwan, as an innovative and reliable partner, will be contributing to the improvement and the development of global plastic and rubber industry ecosystem as it has always done. Finally, I wish all of you an enjoyable time at the forum. Thank you very much, and the best wishes for the success of your business.
Thank you to Deputy Director General Lee. And now we would like to start with the session 1, Circular Economy for Plastics and Rubber. First, we would like to invite Mr. Kinhwa Che, Managing Director of BASF Taiwan, and he will talk about plastic circular economy at BASF.
A very good morning, ladies and gentlemen. My name is Kinhwa Che. I'm the Managing Director of BASF Taiwan and based in Taipei. Thank you very much to the organizer for inviting BASF to share with you plastic circular economy at BASF. Okay, let me give a quick introduction of BASF. So BASF is one of the leading chemical companies in the world. Our chemistry is used in almost all industries. We combine economic success, social responsibility, and environmental protection. And our sales in 2020 in total was close to 60 billion euros with an EBIT before special items of 3.6 billion euros. We have about 110,000 employees worldwide as of end of last year, with 6 Verbund sites, or what we call integrated production networks, and 240 other production sites worldwide. And globally, we serve around 90,000 customers from various sectors. So our purpose is we create chemistry for a sustainable future. And it's very appropriate, that we would like to talk about plastics in circular economy. So where are we today when we talk about plastic waste? According to the Breaking the Plastic Wave report by Pew, there is about 250 million tons of plastic waste being generated annually. And only 20% of these is actually undergoing mechanical recycling. About 40% is disposed either in landfill or being incinerated. And another 40% is mismanaged, meaning they are burned openly or they pollute into the terrestrial areas or in the ocean. And it is estimated that more than 400 million tons of plastic waste will be generated come 2040. So if we don't do anything about it. So this is how it is like in the linear economy. So let me now take a look at the plastics in the different types of economies, linear, recycling, and circular. So in a linear economy, it is an area where we consume a very large amount of resources. And at the same time, it also generates significant waste. And part of this is mismanaged. And of course, in this economy, linear, it will be high carbon footprint. So let's take a look also at the plastics value chain and what are some of the first levers, measures that we can address the plastic waste. So as usual, you are all experts. Plastics is produced from refinery. You get naphtha, put into the steam crackers, then you produce basic chemicals, and you undergo the polymer production to produce the polymers of plastics and used to produce the various products, whether it's injection molded, blow molded, extruded, and so on. And after the use of this plastic, they become plastic waste. Now, some of the first measures that we can look at this is really to reduce the consumption of plastic. Number 2, we can substitute. 3, we can also reduce the mismanaged waste. And 4, you have to improve the way they are being disposed. Yeah? So let me take you through some of this in detail. So in reduction, we can reduce the use of plastics, or what we call single-use plastics. How do we do that? We eliminate it. We avoid extra packaging. Industries, manufacturers can use less and less extra packaging. Avoid single-use plastic items by the consumers like you and I. Or we reuse some of the plastic items. Plastic bags, food packaging, can be reused. Or we have to come up with new delivery models. For example, a bottle return systems put in place. For example, in Germany, if you buy a bottle of beer or milk, they come in glass bottles, and you have to pay a deposit in advance. And after consuming, when you return the bottles, you get back your deposit. Yeah. Or in industries, you have to reuse wooden pallets or even plastic pallets. So next, substitution. So we can substitute by other materials, for example, paper or compostables. Now, when you talk about substitution by paper, we are talking about shopping bags, straws, or even eliminating these altogether, or substitution by coated paper in plates, utensils, food containers, or food packaging. And the better way would also be by substitution of compostables. Yeah? So in BASF, we have biodegradable EcoVio bags, which can be used as carriers, organic foods carriers, and so on, which I will talk about later on. And the government can also create the infrastructure to enable the industrial composting of these materials. So what needs to be done when we talk about reducing mismanaged waste? What happens to the mismanaged waste actually? They are burnt openly, as I mentioned. So the government and industry should look at establishing appropriate facilities to address this. We have to educate and engage the communities to educate so that people will avoid burning or terrestrial pollution or even ocean pollution. We need to expand our waste collection rates, reduce the plastic waste exports, and create the facilities to dispose this. So plastic waste in the environment, particularly in the ocean, is a serious global challenge that calls for swift actions and strong leadership. And to this end, BASF is one of the co-founders of the Global Alliance to End Plastic Waste. It was established in 2019, and currently, as we talk, there are about 60 member companies. And the vision here is to end plastic waste in the environment. And the funding commitment by these companies is to have more than $1 billion, and the goal is to invest more than $1.5 billion over the next 5 years. Yeah, to basically create the infrastructure, to innovate, to educate and engage, and to clean up the ocean and the environment. So what needs to be done when you talk about improving the disposal? So they can be chemical conversions where plastic is converted to fuel by improving the thermal process to transform plastic waste to fuel. And in landfilling, create the facilities to dispose as a transitional measure. Of course, there must be legislative measures for zero plastics to landfill. And in incineration, we can maximize the recycling alternatives through sorting and also building state-of-the-art energy recovery systems. So after having talked about plastics in the linear economy, let's move on to look at plastics in the recycling economy. So as you can see from the picture, in the recycling economy, maybe less resources are being consumed from the planet. It generates less waste and also reduce in the mismanaged waste, and also giving out lower carbon footprint compared to a linear economy. So you can see from the diagram in the same plastic value chain. So from the plastic waste, you undergo mechanical recycling, where the waste polymer is converted, broken down back to polymer again for the reuse in the plastic production. So in mechanical recycling, we talk about closed loop or open loop. In a closed loop situation, the plastics is recycled back to its original material. So examples could involve PET bottles, newspaper, glass, and also the design, will have to be suitable for recyclability. But in the open loop, the recycle will be different. The plastics will be recycled to a different type of products. For example, from bottles to bags, and from apparels, clothing to carpets. And this will increase, government needs to increase the waste sorting infrastructure to really enable this. Now next, let's look at the plastics in a circular economy. Yeah, this will, on the right-hand side of the diagram, you see that this will be the lowest demand of resource consumption. It will generate the minimum waste and also provide the lowest carbon footprint. So here are some innovative examples for recycling enablement by BASF. Because chemical recycling is an innovation to close the loop in the chemical industry. So you see, number 6, depolymerization of the plastic waste. Basically, we break down the polymers into monomers, the building blocks of plastics, and you produce plastics again. Or the number 7, pyrolysis, where the waste polymers is actually undergoing high temperature to be converted into pyrolysis oil, which is a raw material that is added back into naphtha in the steam cracker to produce basic chemicals, the basic building blocks again, in order to produce polymers. So what needs to be done in the chemical recycling? I mentioned about depolymerization and pyrolysis. And what is needed here is improved waste sorting infrastructure. You have to create a supportive regulatory environment to enable this. So let me now move on to give an overview of BASF's circular economy program. Now, as many of you are aware, a circular economy aims to decouple growth from resource consumption and is regenerative by design. So in order to do this, we need to rethink design and use of resources and keep them in use for as long as possible. And we want to recover and recycle products and materials in order to avoid waste and pollution and therefore protect our natural systems. Now this picture shows a summary of the circular economy at BASF. So as in all chemical production, the starting point, the basic building block is fill and feedstock raw materials. So this will be used to produce chemical intermediates, and the chemical intermediates are then used to produce plastics, which we do. The plastics are then converted, through processes or into devices, like mobile phones and cars, apparels, packaging that you and I use every day. So after the consumer use phase, at the end of his life, so these wastes are then collected and sorted. Part of this can be used again as raw materials. So going back into the circular loop again, for production of chemical intermediates and plastics. For those that cannot be used as feedstock, again, they will be disposed in a managed way. And some of them will be incinerated with energy recovery and also capturing the CO2 in order to minimize the CO2 emission to our planet. So how do we drive circular economy in BASF? First, we have to set targets as well as make commitments. So our target is to double the circular sales to reach 17 billion euros by 2030. And we are committed to use 250,000 tons of recycled feedstock by 2025 globally. And we act by running a circular economy program to accelerate this transition. So we aim to achieve this circular sales through our 2 portfolio concepts. One is closing the loop, and the other is extending the loop, which I will discuss later on. So we act in 3 areas. One is circular feedstocks, 2 new material cycles, and 3 new business models. So in circular feedstocks, we will increase the volume of renewable and recycled feedstocks from sustainable sources, also via the certified mass balance approach. And in new material cycles, we design materials for circularity, develop solutions which improve or enable recycling, and establish product-specific recycling loops. And also in new business models, we enter new markets, create smart digital solutions, and offer new services which allow a decoupling of growth from resource consumption. So let me talk about circular feedstocks, chemcycling, and biomass balance. So by using alternative materials, we can manufacture the same products in a more sustainable way. So for example, in renewable feedstocks, we have the biomass balance portfolio, where they are derived from biomass waste of agricultural production, crop or food processing or residues. And we also have a dedicated bio-based portfolio, where we source these raw materials sustainably. For example, the roundtable for sustainable palm oil. Yeah. So in recycled feedstock, for example, chemcycling, these raw materials are derived from post-consumer plastic waste or even tires. Now, chemcycling is a complementary approach and not in competition to existing recycling methods like mechanical recycling. We contribute to the recycling of plastic waste for which no high-value recycling processes are established yet. So many a times, the plastic waste that we find today are mixed. They are not a single type of a plastic. It is mixed, for example, with food residues or different types of polymers or multi-layered food packaging or in tires. So they cannot be easily recycled using the mechanical way. And therefore, using chemcycling will overall increase the recycling rates of plastic waste. Now, this is a diagram that shows the chemcycling project in BASF. Consumers use and dispose plastic products like today. We collect and sort the plastic waste also like today. Then we convert the plastic waste into pyrolysis oil. And using the purified pyrolysis oil as feedstock in our Verbund production or integrated production network systems, we will produce the chemicals. And then we use a certified mass balance approach to allocate the recycled feedstock to the chemicals produced. And customers use chemicals for their own products, and the cycle repeats itself. So with chemcycling, we turn plastic waste into virgin-grade high-performance materials that have the same level of quality and purity as virgin plastics. And this makes it possible for manufacturers to produce products with recycled content that have to meet very high quality and hygiene standards, for example, in some food packaging applications. So chemcycling is also attractive in terms of CO2 emission. The results of an external critically reviewed life cycle assessment for chemcycling showed that chemcycling emits 50% less CO2 in comparison to incineration of mixed plastic waste. So manufacturing new plastics out of mechanical or chemical recycled feedstock also showed comparable CO2 emissions. So as you can see from this slide, it is not just one specific measure. I mentioned about 7 different levers here that can help to reduce CO2 emission in our circular economy. So a life cycle analysis takes carbon footprint into account. A simple mechanical recycling typically has a lower carbon footprint, but not everything can be mechanical recycled economically or technically. So chemcycling has a lower footprint than incineration and is circular. So let's go back to one of the charts, in the Breaking the Plastic Wave report by Pew again. So you see that the circular economy will be the biggest lever in terms of reducing plastic waste in the environment. So by reducing, by substituting, recycling, and disposing. Next, the biomass balance approach, where we replace fossil resources in the current production Verbund. So what happens here is that we use more renewable feedstock, which is in the very first steps of our chemical production, like in the steam crackers. We add to the fossil fuels, as a combination. So then it goes through the entire production Verbund again to produce the various different chemicals. And we allocate this renewable feedstock to the final conventional or products that we have produced, and thereby creating a portfolio of biomass balance products. So this biomass balance approach requires no reformulation to produce the products. The renewable feedstock is available and is easy and fast to be applied for all of our products. It saves fossil resources and reduces greenhouse gas emissions, and hence drives the use of sustainable renewable feedstock. Now, on closing the loops or new material cycles, I will give some examples here. So one very good example is the biodegradable and bio-based polymers that are branded as EcoVio and EcoFlex in BASF. They are industrial compostable, and they are used for organic waste bags, fruits and vegetable bags, carrier bags with dual use, packaging applications, and also in agricultural mulch films. Let me give you one day-to-day example. When we go to a grocery store, supermarket to buy groceries, we bring our shopping bag using a plastic carrier. Now, if this carrier is a compostable, biodegradable plastic bag, we can actually bring the goods home, and then when we are done with the fruits and vegetables in preparing our food, it can also be used as organic waste bags, yeah, to throw away the leftover vegetables or organic waste. Now, with a very good waste sorting system infrastructure in place, this whole waste bag can actually be sent to industrial composting facilities to be composted. And the compost can then be reused, as fertilizers and so on, thus bringing the CO2 back into the loop again. The EcoFlex is a fossil-based product from BASF that's suited for the production of flexible films in the packaging industry. So another example is really putting the mattress waste problem to bed. And it is a pilot project in Germany, working with a partner to collect, recover the high-quality polyols from old mattresses. Because in Europe, in every year, almost 30 million mattresses are thrown away. And we do this by a chemical recycling process that breaks down the flexible polyurethane foams and enables a closed loop. Next is extending the loop, making the products more durable, last longer, and so on. So one example is our light stabilizer, Tinuvin. Now, the exceptional light stabilization property extends the lifetime of agricultural films by up to 60%. Now, this enhanced film protection and light transmission increases the productivity, improves crop quality, and reduces plastic waste. It also protects the films against very high levels of ultraviolet radiation, heat, and agrochemicals. And is designed to be compatible with organic farming, also with integrated pest management. Another very nice example is Infinergy, or our expanded thermoplastic polyurethane used in the application of sports footwear, in the midsole. It is providing a longer lifetime of the shoes and better durability compared to the very commonly used materials, the ethylene vinyl acetate, or EVA. It saves resources. It enables simplified design and production processes. It also gives the brand owners and manufacturers the option for a recycling concept of shoes, for example, a one-material shoes. Next, new business models. We also contribute to the circular economy by coming up with new business models. Now, this is a very cool example on how chemistry can contribute. One of our subsidiary, wholly owned subsidiary, called Trinamics, that was founded in 2015, they have developed a mobile near-infrared spectroscopy solution, which is able to identify plastics for easier sorting. So let me describe the usage. It comes with a handheld device. You bring it to scan the material, the plastic material that you want to determine the composition. And the data will be sent to our cloud database for analysis. And within a few seconds, you will get the results, the exact composition of the different types of plastics. Now, with this technology, we can precisely determine the diverse compositions of different plastics, and we can distinguish via simple use of a portable handheld device, using a mobile app. So this recycling and recyclability are then improved, paying off for both the environment and businesses alike. So we need to drive changes together. Nobody can do this alone, and we cannot be successful if we are not doing it together. So today, various players across all markets have already set ambitious circular economy targets. Legislators have also imposed levies for the non-recycled plastic packaging waste. And also in the investors community, various funds had been set up with focus on circular economy. All these lead to the scenario where the GDP growth will be driven very much by circular economy. So the chemical industry is a key lever for plastics economy. So there are external factors driving this shift. For example, technology shifts, consumption changes of people, new regulations. But the chemical industry can contribute by extending the loop as well as closing the loop. So the demand in downstream markets and consumer behavior, like you and I in our choices, will be decisive. So Of course, on the way to circular economy is not a walk in the park. There are many challenges that need to be tackled. So we need cross-value chain collaboration to form new partnerships, and nobody can do it alone. In technology, we have to have development of recycling techniques and also ensuring purity of the materials to be recycled. There must be also availability of waste as raw materials at suitable conditions, in quality, price, and volume, as well as overcoming some of the regulatory challenges. There's also a mindset shift needed from the take, make, and dispose, the linear model, to a circular model, or reuse. Yeah. And of course, I talked about certification and regulations, and last but not least, infrastructure, developing suitable systems for the end of life or for the waste streams. So circular economy is a big network that we need to plug ourselves into that requires dialogue, partnership with the stakeholders. So we engage in various networks to better understand the trends in society, the drivers of our business, and then we help to shape measurements and performance standards. So in Taiwan itself, there is a Taiwan Circular Economy Network that we are also working very closely with on such topics. And this brings me to the end of my presentation. Thank you very much for your attention.
Thank you very much for your presentation.
Next, we're going to invite Mr. Samuel Yap, Technical Manager of Chemical Division of Milliken Asia, and he will talk about sustainability and energy savings, harness cycle time reduction, and increase productivity via performance additive. Please welcome Mr. Samuel Yap.
Okay, good morning. 早上好. Thank you for giving us time today to share. My name is Samuel Yap, and I'm from Milliken Chemical. And today we will share about sustainability and energy savings, harnessing cycle time reduction, and increased productivity via performance additives. So to start, let me briefly share what is Milliken all about as a company. So we are a multinational company, headquarters in the United States, more than 7,000 employees, more than 65 global locations, and more than 14 countries where we are actively developing our business and our manufacturing as well. And for me, I'm actually speaking from Singapore, but we are very active in the whole of Asia, of course in Taiwan as well. So we are a diversified company. What I'm sharing today is part of the chemicals business of Milliken, but we also have flooring, which is the carpets, healthcare, mainly the bandages, all sort of textiles, specialty textiles for fabrics and for uniforms. So today we are actually talking a bit about sustainability and how Milliken's solutions can help sustainability. But not just the chemicals, but the whole company has really started this sustainability drive. And here is just to share some of the various sustainability drives and mission that the Milliken as a company as a whole is really doing in the past few years. So for our fabric, polyester fabric, of course, it is PET. So there is a big recycling campaign, try to use PET plastic bottles really to make recycled fibers for our textiles. And we have won some sustainability award. So our carpets, right? Our carpets, a lot of environmental pressures that we need to be free from a lot of different chemicals that are not helpful or are harmful for our bodies and our health. So a lot of our carpets are in this wet list free. More fabrics, this is flame resistant fabrics. So we help those in the dangerous industry that, with the fabrics, it can be flame resistant. We have been ISO 9000 for 25 years. And of course, now it includes what we do for sustainability as well. Another story about our carpets. So we are trying to use more and more recycled content in carpets as well. So up to 50, 60% in some of our modular carpets. And now a couple of stories about the chemicals business of Milliken. and I will talk more about this, which is Millard NX8000, our premium clarifier solution for PP, helping to save 10 to 15% energy. And also I will be talking today about Delta Max, one of our newest additive performance modifiers for both virgin and also post-consumer, post-industrial recycled, and also helping to save energy savings during production. So talking about sustainability, especially in the plastics or the polymer world, right? I think this is a complicated chart, but really the life cycle of plastic parts, and every part from the recycling, from the new feedstock, recyclable feedstocks, design, production, use, reuse, and also all the recycled or energy recovery. And of course, we want to avoid leakage as much as possible. This is really the whole life cycle and sustainability cycle that we try to promote and work together as an industry, as a community, as the whole world to reduce plastics waste, to be more sustainable in the plastics use. But you can see there's a lot of recycling, a lot of feedstocks, and a lot of collection and avoid leakage. But there is also the design and especially the production of plastic parts, which we sometimes neglect to talk about, but it is also a very important aspect of sustainability. How can we design and use production services or production methods or production settings which maximizes the sustainability that we can get? And today's talk actually is really focusing on injection molding production processes and how specific high performance additives can help to maximize the sustainability benefit even during the production. So we will talk about three of Milliken's major additive solutions. Number one is Millard NX8000. It is a clarifying agent for polypropylene to make it clear and very transparent. But this is the latest generation that also provides energy savings, and we will talk about it later. Hyperform HPN is a nucleating additive range. Again, nucleating agent have a lot of benefits for polypropylene, and one of the major one is the increase of quicker cooling time, and therefore you reduce your cycle time. And finally, briefly mention about the Delta Max performance modifiers. This is one of our newest product line, and we will also see how it can help in the injection molding process to save energy and to have a better sustainability benefits. So first of all, Millard NX8000 clarifying agent, and I'm going to talk about the UL green label that is already available for Millard NX8000. And I would like to start with a video first, so please enjoy.
Do you know? How to let PP be made at the source of production that is environmentally friendly, energy saving, and highly efficient is what we are constantly concerned about compared with traditional polypropylene clarifying agent. Having Millard NX8000 clarifying agent in the injection molding process can effectively shorten the molding cycle, reduce injection temperature and energy consumption by up to 10%. Hyperform HPN not only has excellent energy saving effects, but can even shorten the cycle time. Improving production efficiency provides possibility. Thanks to efficient and energy-saving injection molding processing technology, Milliken products have been independently certified by UL and was conferred by the UL Environmental Declaration Verification. Being the most trusted in the world as one of the third-party product safety and standard development institutions, the market fully trusts UL-issued Sustainability Declaration verification. If we produce 1,000 tons of Millard NX8000 PP injection molding products to replace ordinary plastic products, it is equivalent to saving 3,672 hours of production time, which is approximately $150,000 worth of expenses, a reduction of 4.1 cars' annual fuel consumption, decreasing carbon dioxide emission by 11.8%, which protects 18,210 square meters of forest area, equivalent to 2.5 times the size of a standard football field. Similarly, if you use high-perform HPN to produce thin-walled products, you not only can reduce energy consumption of around 5 to 8% on average. When a single material is used for takeout packaging, it will be more convenient for unified recycling and reusing. If you need more information about UL, please contact a Milliken representative near you. Come and join us, and together we will protect the world and the environment. chemical.milliken.com.
All right, so that was a quick 3 minutes video talking about the UL and how Milat NX8000 can help in energy savings. Let me go through a little bit deeper, step by step, on what do we mean and how you can also apply, or anyone can apply, this concept in your injection molding machine. So NX8000 is a clarifier. It is used to make the polypropylene parts more transparent. And before we launched NX8000, there were already other traditional clarifier solutions in the market. But the traditional clarifier solutions had a downside, have a negative point where you need high processing temperature, high injection molding melt temperature to achieve the low haze. So haze is a measurement of the transparency, and low haze is high transparency, good transparency. But if you use low temperature, reduce your injection temperature, the haze will go up, which means the product will be less transparent. For example, high temperature, transparent product. And if you reduce the processing temperature, you can see that the product will be less transparent. So that is the drawback of the previous traditional clarifier, and people need to use high temperature all the time to achieve what is required. When we launched Milat NX8000, one of the strong points is a very flat processing curve, right? It's a very robust processing window. No matter what temperature that you use for injection molding, you get similar, very low haze, very bright, very transparent products. So how do we leverage the low temperature processing of NX8000 to achieve better energy consumption and higher productivity? Right? If you now think about injection temperature at the x-axis and also cycle time in the y-axis, and assuming you start, you have been using traditional clarifier polypropylene grades in the past, you are used to using high injection molding temperature to get the clarity that you need in your part. And you need a certain cycle time, which is usually high, because if your melt temperature is high, you need more time on the cooling stage for it to be able to cool down, solidify, and demold or ejected properly. So high temperature, you need more time for cooling, therefore you need high cycle time. And the size of the bubble here, we try to illustrate or demonstrate the energy consumption. How much energy that you need to use to process 1 kg or 1 ton of polypropylene. And so as you reduce the melt temperature, the processing temperature, because now you do not have the blockage, right? You use low temperature, you still get a good part, perfect part. Since you are using a lower temperature for the melt temperature, usually you can afford to reduce the cycle time, especially the cooling time in the mold. The same concept, if you use a less hot or colder melt, pushing it into the mold, you need less time to cool the part in the mold before it can be ejected properly. And therefore, by reduction of temperature, you need less electricity to heat your heater bank, and especially you reduce the cycle time, productivity increase, right? Last time 1 hour you can make 100 parts, now 1 hour you can make 110 parts. And if you calculate the energy that is used for every part or every kilogram or every ton of material, that is a significant savings. What happens actually is not just about clarity, but there is also a lot of undesirable defects if you use traditional clarifier and you try to especially reduce the melt temperature. We already say that the clarity will be different. This is NX8000, this is traditional clarifier at low temperature processing. You can see a lot of defects, white streaks, white marks, undispersed additives if you use traditional clarifier at low temperature, and no problem with NX8000. And also voids. Voids are like air bubbles, right? In the part, and especially for syringes, injection syringes nowadays, very important in this COVID situation for vaccination. Syringes are very sensitive for voids, which are these bubbles, defects, which is in the plastic parts, very easily seen if you use traditional clarifier at low temperature. And of course, it is undesirable. The nurses and the doctors will be confused whether this is the air in the medicine or it is just a void in the syringe itself. So usually trouble-free, no voids, no defects, high clarity with low temperature processing, available or applicable with MILAB NX8000. And we move forward, right? We have demonstrated many, many times with a lot of customers, a lot of molding, that since you can reduce temperature and also reduce cycle time, on average, we can save around 10% of energy savings per part or per metric ton produced. An average 10% of energy savings just by using state-of-the-art modern additive, and therefore you can adjust your processing conditions. And what does 10% means, right? 10% energy savings, of course, you pay less for your electricity bill, but the electricity that we use also comes from a power plant, which have to emit CO2 emission when they make the electricity, right? So if you use, or if more and more people adopt this technology and save 10% during processing, you can also save 10% of reduced CO2 emission generally. And we can give you some examples on what it means by 10% energy savings. So let's assume a customer processes 8,000 tons of polypropylene in 1 year. They might be making parts, injection molding, they use polypropylene, and now they're using NX8000 type of additive in their clear polypropylene. By processing 8,000 tons of polypropylene, but overall saving 10%, you can calculate it to be more or less like the CO2 which is absorbed by 74 acres of forest each year, the amount of CO2 absorbed by greenery or by plants. Or you can calculate it as equivalent to 68 cars running per year, right? Saving 10% maybe per molder is equivalent to about 70 cars reduction of the pollution or CO2 emission. So everybody doing its part can quickly add up. And this label, this green label, we work with Underwriters Laboratory, which is a trusted third-party non-profit organization. And they have validated that this is confirmed, real, audited, will be able to save on average 10% energy savings. They have an audit plan. We give them a lot of data. And now any customer, any molder, anybody in our supply chain who uses polypropylene with NX8000 can work with us, work with UL, and use this green label on your product, on your data sheet, on your brochure, on your website, as really an education to show the world, to show the industry that, hey, we are trying our best. We are also using the most modern technology and we are helping the world. So talk to us if you are using NX8000 in polypropylene. We can talk together with UL, and this can be validated and be used as part of your packaging or part of your brochures as well, the UL green label. Right, so some of the real data that we have conducted and we can still support to help to conduct energy savings trial. On average, 10% reduction in cycle time, on average, 7 to 25% reduction in CO2. And here are some of the examples of polypropylene injection molded parts, which we have done trials with a lot of customers in the past, a pump, a closure, containers, tin wall containers for food. And you can see, of course, depending on your mode, depending on your machine, depending on the cost of electricity that is in your plant. But on average, this is what we are getting. And this is how we can use one of the examples using the UL label in, let's say, your parts that you can stick on it or print on it. And then that really shows the world that, hey, we are doing our part for sustainability as well. All right, that is a quick sharing, a quick story about NX8000, the energy savings, the UL label. And since then, we have extended that UL label program to our high-perform HPN additives as well. And for high-perform HPN, the data that we collected and submitted to UL, they have validated to be between 5 to 8% of energy savings, especially focused on tin wall injection molding. So it is the same concept. For this case, for HPN, compared to a product which is not using HPN, most of the energy savings is not about injection molding temperature, but it's more focused on cycle time. So HPN has a lot of benefits for polypropylene parts. And I will not go through all of them, but you can look through some of the benefits, some of the advantages, or some of the value proposition of HPN into polypropylene. But one of them is faster production rate, because HPN controls and quickens, makes the crystallinity and the solidification of PP faster. Again, reducing cooling time, reducing cycle time, because you need less cooling. With HPN, you make the parts quick, solidify faster, and you can eject it. And like we say, a lot of data calculated on average 5 to 8%. But really, shrinkage control, stiffness improvement, dimensional control, especially if you use different colors, and even some barrier improvement in some HDP in this case. But today, of course, we are focused on the sustainability aspect, definitely the cycle time reduction. And finally, Deltamax, right? Deltamax is the third family of specialty additive for polypropylene in our family. Quite a successful launch in the past few years. And what is Deltamax all about? Number one, it is really focused on impact copolymer. Impact copolymer polypropylene. It does not work on purely homopolymer or purely random polymer. But if you have impact copolymer, which has the ethylene propylene rubber, or if you use polypropylene and you add in external rubber, we can also use Deltamax for this. But let's talk about impact copolymer, right? Impact copolymer polypropylene. Why people choose to use impact copolymer? Because of the impact strength, right? You need a part which is tough, which can be used for many years. You can drop it and it doesn't break. So you want a certain high impact strength for your part requirements. On the other hand, during processing, during injection molding of the part, the molders wish to have higher melt flow, higher MFR. With higher MFR nowadays, quicker processing, reduced temperature during processing, parts which are designed to be thinner but still strong, parts which are getting larger and larger. Therefore, you need easier processing polymer with high MFR to flow properly. But you can see the trend, right? There is a tension between impact strength and melt flow. If you need very high impact strength, you need a very tough impact of polymer, polypropylene. A lot of the time, you are limited to the melt flow that you can achieve or the melt flow that is available with the high impact strength. On the other hand, if you want easy processing and you select a very high MFR material, most of the time the impact strength is very low, right? And this is the space where there is an unmet need. There is an unmet need for high MFR and also high impact polypropylene. And if we go down a little bit deeper, yes, there are other impact modifier solutions already in the market. High rubber impact modifier, very soft material. You can blend it in. You might be able to achieve certain high impact strength and certain melt flow. But the third dimension is the stiffness. You put in all these traditional impact modifier, the part gets softer and softer, whereas Deltamax will not have significant change to stiffness. So I like to share the story of Deltamax in the name of Deltamax. Delta is the Greek alphabet for D, delta, right? And in the Greek alphabet, the capital delta is the shape of a triangle. So we want to maximize this triangle, maximize the impact, maximize the melt flow, and maximize the stiffness as well. So for example here, we can use Deltamax to make one impact of polymer grade, which has 80 MFR, right? We work with a partner and we develop this 80 MFR impact of polymer, very high MFR, and the impact performance and also the stiffness performance of this high MFR, 80 MFR, is similar to the traditional 40 MFR. So in the past, if you need the toughness of a 40 MFR, you are stuck with the 40 MFR, right? If you try to get a higher MFR because you want to have easier processability, there are no such grades available. But now with Deltamax, with some of our partners, we have launched this 80 MFR ICP with the same toughness and the same stiffness. And so we work with Modex 3D. We work with also based in Taiwan. It's a CAE, right? Computer Aided Engineering software, which try to simulate. So in this case, we choose automotive part, instrument panel, big, complicated, many runners, and you can see as you inject into it a lot of complicated flow paths. So in the past, if you are using 40 MFR, you might be forced to run at 230 degrees, for an example, because you need certain high temperature for it to flow properly. Deltamax, making this 80 MFR ICP, similar toughness, similar stiffness, but with higher flow, we can afford to reduce the injection molding temperature from 230 to 200 degrees. And you can see it is still flowing very smoothly because of the higher MFR to fill the whole part. And the flow time is not so much difference between these two parts. And if you would have tried previously using the 40 MI and reduce the temperature, you would likely run into many other problems with shorts, too much pressure, that it will not be able to fill properly. So the same idea, 230 to reduction to 200. Same general ideas that we have been sharing for the other concepts as well. Reduction in temperature means usually you can reduce the cycle time, because the same idea, if you are injecting something which is not as hot, you need less time to cool it in the mold before you inject it. So also a real example, a real trial of this big crates, heavy-duty crates that you need certain impact strength requirements. You can reduce the energy required to process per kg or per part, reduction here by 12.5%, right? So this case was 36% processing temperature, 12.5% energy savings, 20% in the cycle time. And if you calculate for this particular case, the molder, they can add 58 days of added capacity or more than 100,000 additional parts per year. So this particular case was boosting the MFR 5 times. So for example, maybe they start with a 20 MFR, you can shoot it to 100 MFR without sacrificing the impact. So another similar concept, molding or injection optimization by using specialized additives. The other part about Deltamax is that it is well suited for recycled as well. It is not just an additive for recycling, right? It will also be used for any polypropylene impact copolymer, virgin or recycled. But we know, especially for recycle, whether it's post-consumer, pre-consumer or post-consumer, there is always a big variation of the recycled material. And we are talking again about impact copolymer recycle. Sometimes the impact is low, sometimes the impact is high, sometimes the MFR is low, sometimes the MFR is high. So by improving the mechanical properties, like what we shared just now, pushing the MFR higher, more consistent, so that you can injection mold it more easier, right? At the same time, preserve and conserve the impact that is required, and sometimes can actually improve the impact of the product, and therefore you avoid one of the difficulty of variation of incoming raw material in recycled polypropylene. But the same ideas about reduced recycle time, reduce energy consumption, because you can afford to use lower injection melt temperature since you are using a higher MFR product due to Deltamax. And so talking more about recycle, right? What is the benefit of using recycle? There is many studies looking at many different benefits of using recycled polymer. It doesn't matter what type of polymer, but recycled polymer versus using a virgin polymer, right? Whether it's total energy of the whole life cycle of the virgin versus the recycle, whether it's water consumption, the generation of solid waste, of course, global warming, and other more specific parts of the impact to the world, right? So Deltamax is being used to solve this sort of problems, to upgrade the incoming recycled impact of polymer streams so that it can be used in more applications, and even during use, we can reduce the energy consumption. Right, so as a conclusion, let me refresh again. We have shared today 3 of the main families of high performance additive, especially for polypropylene, that we are offering from Milliken Chemical. Millard NX 8000, clarifying agent, making the polypropylene very transparent, but with this new generation of lower melt temperature processing, up to 10 to 15% energy savings, and the possibility to apply for the UL Green label. Very similar, the high-perform HPN performance additives, by the nature of increasing crystallinity, also can reduce the cooling time and the cycle time 5 to 8% for polypropylene injection molding part. Again, available to use the UL Green label program as well. And finally, our newest Deltamax improved MFR, melt flow, and also improve impact performance at the same time, so that you can also upgrade your recycle, but overall reduce energy savings, reduce the melt temperature, reduce the cycle time. So thank you very much again for today. It was a brief talk, just some of the maybe less paid attention part of the whole sustainability cycle, right? Really, yeah, we can always focus on collection of waste, recycle of waste, use non-fossil feedstock. But also today it's good to just have a reminder that we can optimize every part of the cycle. And today we have presented 3 solutions to optimize the processing part of making an injection molding part and helping the overall sustainability goals of our world as well. So thank you very much. Have a good day. Thank you.
Thank you, Mr. Samuel Yip. And now we would like to move on to the panel discussion. Please use the Slido system to raise your questions. You can scan a QR code to raise your question. You can also like other people's question. So in this panel discussion, we have invited Mr. Yao Gui Xiao, General Manager of Plastic Industry Development Center, to be our moderator. And our panelists include Mr. Kinhua Che, Managing Director of BASF Taiwan, Casey Su, Commercial Director of LCY Chemical Corp., John Chan, Chairman of Living Fountain Plastic Industrial Cooperation. Now we'll give the floor to our moderator. Dear panelists, ladies and gentlemen, good morning. First, I would like to welcome all of you to the Plastics and Rubber Industry Trends Forum, organized by the Bureau of Foreign Trade of MOEA and TITRA. So in the morning session of the forum, we talked about circular economy for plastics and rubber. In the afternoon, we have other 2 topics on Plastics on the Move and Medical Magic by Plastics. I'm the moderator of the session. I'm the General Manager of Plastics Industry Development Center, PIDC. Before we begin, please allow me to introduce our 3 panelists. On my left, this is Mr. Kinhua Che, Managing Director of BASF Taiwan. Managing Director Che is used to serve in the Bureau of Economy of Singapore. So later he worked at BASF, so he has been devoted to the development of his company. So he has over 20 years of experience in the industry. So this morning, he also gave us a wonderful presentation about the efforts done by BASF on promoting circular economy. So I look forward to his insights later. Our next panelist is Mr. Casey Su, Commercial Director of LCY Chemical Corporation. Mr. Su has a wealth of experience in thermoplastics. LCY Chemicals has done a very good job in this regard. So we also would like to ask Mr. Su about his experience. Also, Milliken shared with us the efforts in the use of adhesives in PP. So I think Mr. Su is an expert in this area. They have greater use experience. So probably Mr. Su can share with us his insights later. Our third panelist is Mr. John Chan, Chairman of Living Fountain Plastic Industrial Corporation. I've known Mr. Chan for many years. He's my good friend. After graduating from National Taiwan University, he started his company when he was a senior. So Mr. Chan is a successful entrepreneur and he's very committed to charity. So every time when I see him, he's working in these charitable work, and he also serves as the chairperson of the Taichung Plastic Association. So when he's promoting the food packaging and medical packaging by using plastics, we would like to learn from his experience. Our 3 panelists have a wealth of experience in their professional area, so we look forward to hearing from them. So to kick off, I would like to direct my question to Managing Director Che of BASF. Managing Director Che, when introducing the headquarters of BASF in promoting circular economy, they start with setting the goal to fulfilling commitment to designing the technology and implementing all sorts of loops, and they have physical and chemical recycling. They have a very comprehensive process. So I have some more questions for Managing Director Che. One thing that drew my attention is that in terms of the recycling of mixed plastics, that was really difficult. In your introduction, I think there are two interesting technologies. The first is chemical recycling. In addition to the two ways, you talk about chemical recycling that may be more comprehensive and that can help purification and add higher values. So my first question for you is that in terms of chemical recycling, what's their current status, especially in Taiwan? Are you also conducting chemical recycling in Taiwan? Secondly, I think if we can recycle the plastics and have good sorting, I think that can help lower the difficulty. But the difficulty actually lies in the mixture of plastics. How can we sort out the plastics? What kind of plastics are contained in the great mixture? So I think that's the great difficulty. And Mr. Che, in your introduction, when introducing BSF, you have the carry-on IR sorting, a spectrometer, a handheld device to identify the type of plastics. I think sorting out or identifying the plastics will be very helpful and useful. So I would like to know more about this technology. Do you have any user experience to share with us, or probably you can tell us a bit more? How can we use these tools or devices to help with the recycling of plastics? So these are my questions for you.
Yeah, for your two questions, which I've listened using your Mandarin, yeah, without the translation. But I will give my answers in English. Yeah. So as you have heard earlier on, I talk about recycling. Yeah. One is mechanical recycling, and the other one is chemical recycling, or chem cycling, as we trademarked it. Yeah. So I mean, the difference here is, as we have already explained, you have also mentioned that sometimes the plastic waste that we get today, they are very mixed. They are not just a single type of plastic. For example, standalone polystyrene, standalone polyethylene, terephthalate, and so on. So when it is all mixed, as you have rightly said, in order to be able to mechanically recycle these plastics, you need to have a very efficient sorting system. And then it will make the mechanical recycling also very efficient. Yeah, very little, very small amount of carbon emission, which is a good measure. Now, however, if you have mixed plastics, or sometimes even worse, you have fats, oils, and grease, and all other things attached to it, then your sorting or your removal of the impurities or contamination will be a little bit much more difficult. Now, then it will be inefficient to sort them out in the first place, let alone the next step, which is the mechanical recycling. And here, the wonderful thing that we have piloted here, worked on since 2018, is to basically break down these mixed plastics with whatever waste into raw materials at very high temperature. They become pyrolysis oil. Yeah, they undergo a process called pyrolysis. Yeah, they turn into oil, which can be then added into the feedstock. And from the feedstock, then you basically start to produce your chemical building blocks again, in order to start producing the other plastics like before, instead of using fossil fuels. So this is the wonderful thing about the chem cycling. Of course, there's also technological topics related to this. How high is the temperature, on the purity of the pyrolysis oil, and so on. So this is still work in progress. There is not yet a super world scale chem cycling type of production. It is in small scale, but already there are consumer products that are produced through this process. So I hope that answers your first question. And for the second question, you talk about this, I mentioned it's a very cool example, the Trinamics handheld device. So it is a near infrared spectroscopy scanner. So what it does is that, you just use it like a barcode scanner. You scan the materials in order to determine the composition. So after scanning, the data will be sent to the cloud, the big database, for analysis. And within a few seconds, you will see the results on your mobile phone app. How many % of polystyrene, how many % of, et cetera, with how much % of confidence level. Yeah, so this makes the sorting very easy. Yeah, and also, because it makes sorting easy, then you know that, okay, this type of materials, you can easily go under mechanical recycling or not, and so on. So this is how we contribute by using digital solutions, smart solutions in order to develop this circular economy.
Thank you very much, Managing Director Che, for your in-depth analysis. You just talked about the handheld IR device for determining the device. Here in Taiwan, in BASF Taiwan, are you selling this kind of device? If other companies are interested, can they acquire this kind of device from BASF Taiwan?
At present, we do not have it on sale yet. Yeah, so we are still using it as a demonstration item. Yeah, so it's a pity that I do not have the device with me today. Otherwise, I can actually do a very quick live demonstration. Yeah, but a very good question. So it is one of our subsidiaries, Trinamics, that has developed this, and now we are looking at where it can be applied, whether there will be interested parties and they will be interested in using such a solution. And overall, yeah. So maybe we can gather more interest, among the Taiwanese manufacturers or related parties. Then we can then start the dialogue to see how we can bring this technology as solution also to Taiwan.
Thank you very much. I think this kind of handheld device is very helpful to the recyclers for plastics and rubber. They definitely will be very interested. So we hope that through today's online platform, we understand BASF Taiwan has this kind of device. So probably our participants online, if you're interested, please contact BASF. Probably they can go and have a look. And we sincerely look forward to the fact that in the future, probably you can introduce this kind of digital solutions to our partners in Taiwan. I think they will be extremely helpful for us to promote recycling. So thank you once again. And thank you for your sharing. Moving on, I would like to direct my question to Mr. Casey Su. Commercial Director Su, we heard from Milliken that they use their adhesive to PP, so they have created a lot of benefits. For example, energy reduction to reduce the cycling time and to improve transparency. LCY Chemical is Milliken's great partner and a great user. So Mr. Su spent a lot of time on the research in this area. So my question for you, in LCY Chemical, how do you find this kind of adhesive in terms of energy conservation and carbon reduction? Can you share with us any data or examples? Thank you. Please allow me to share. NX8000 from Milliken. I think our speaker gave us a wonderful introduction. I can only mention that in addition to the reduction of recycling time and the reduction of energy, recently they have another new advantage due to climate change. Now we can see Europe is making new policies. So cutting carbon footprint is very important. In addition to reducing costs, actually they can see great incentive in the carbon tax. So for us, carbon tax, well, to be honest, the products from Milliken, in terms of energy reduction, it's quite useful. Based on our past using experience, I think the reason why they use it because they want to promote CSR, because they want to reduce carbon emissions. In the past, the cost of carbon emission was not included in the products. But now, as we can see, now people have been talking about carbon tax. It has been hotly discussed topics. And for my company, I think carbon tax will continue to increase due to climate change and extreme weather events. It will only go up. So the products from Milliken can not only help conserve energy, but can also cut down carbon emissions by reducing carbon footprints in the future. I think the products will be even more competitive. So we believe that in the earlier stage, maybe people only thought about energy conservation, but in the future, I believe that the products can even help us save the carbon footprints, and that's even more effective.
Thank you, Mr. Su. To analyze this topic from the perspective of carbon tax and circular economy, we know the new policies issued by Europe, and starting from 2023, all the products imported to European Union and carbon tax will be deducted. So according to the tax price decided in London, I remember that for 1 ton of CO2, the tax is about 40 to 50 euros. So for plastic and rubber production, it consumes a lot of energy in the process, or in the production process. And so starting from the material transportation and the processing and the packaging and the storage, everything is related to our carbon emission. So we thank Mr. Su for his perspective. If we can save energy and to reduce cycle time and to reduce energy consumption, we believe that this is going to be a great advantage. Sometimes when we change the concept, it's actually going to pose a great impact to the industry. In the past, in the plastic industry, when we use the recycled materials, and people would say that we were stealing materials. Now it is called environment friendly. And before, in the past, if we rent our facilities, and people were having a different idea, now we call it shared economy. And so now we are changing the concept, and we're having a different phase of the economy. Another question from Mr. Su. We know that the LCR, and he has been promoting the 6R circular economy, and a lot of companies were asking the details about the 6R. And can you share with us the details of your 6R project? Because in our company, we have a lot of business units. What we can share with you is not probably plastics, and we can talk about plastic later. But for LCY, we have one product called EYCA. So at the beginning, we know that in the electronic industry, they have a high standard of CSR. They hope that all the chemicals they used will not be discharged. So for material companies, they are the one who really understand the materials. And we know that EIPA is one chemicals they use in the production process. And for semiconductor companies and for electronic companies, at the beginning, what they thought of at the beginning was their CSR. They don't want to discharge these waste. Therefore, industrial waste, they should be incinerated, and it's actually very costly. And after, if we recycle these materials, it can create win-win situation, especially in the circular economy. And not many people can achieve win-win situation. And for high-tech industry, if they recycle this material, of course, they don't have to incinerate the material. And for us, we can recycle this material, and we purify it, and we can reuse it. So this approach can benefit both sides. And for us, I can give you one example. Plastics is deemed as a material that will last forever. It is not easily decomposed. So from another perspective, plastic is stable. It lasts for a long time, so they can be reused. it really depends on how you look at it. And so in our company, just like we believe that plastic should be recycled multiple times. And we saw the circular economy diagram very often, the butterfly chart. Of course, the concept is very good. However, in reality, for PCR recycling, yeah, it's actually more costly compared to virgin material. So commercially, is it making any sense? Because for recycling materials, it's not going to be better than the virgin material. And it is more costly. Recycling material is more costly because when you recycle, there is a cost in the recycling process. We see recycled plastic bricks, and those bricks, they have been processed before. For example, the recycled plastics, they were classified into different categories. They have different specifications for the recycling materials. They have different MI value. So if you recycle, if it's one-time recycle, you have to put a lot of time and energy to process these recycled material. So in the past, people might wonder why the recycled material is more expensive. It's because it is not including the external environmental cost in it. But now we see the opportunity because of carbon tax. For carbon tax is actually internalize the external expenses. So in the future, virgin material is going to be more is going to be cheaper than the because now the recycled material includes the external expenses. So for recycled materials, once being certified by third party, and if we can maintain the quality of the recycled materials, of course, there is a high demand in the market. People want it, no matter it's from the carbon tax perspective or the companies wants to contribute their part in saving the planet. People are having a different concept, and people are calculating the cost from a different perspective, and they're now including the external expenses. Now, if we want to develop a good economy approach, of course, we do not want to affect the potential for our next generation. Of course, that is the core concept for circular economy. And Mr. Su also mentioned that for LCY, they provide the materials to the semiconductor industry, and they recycle the chemicals and purify the chemicals, and they reuse the material. And that reflects to what Mr. Xie mentioned, the internal recycling, and you mentioned about the closed loop and extend the loop. And for closed loop, it's actually providing opportunity. And we believe that it is more efficient for closed loop. And next question is for Mr. Zhang Chen, Chairman of Living Fountain Plastic Industrial Corporation. Chairman Zhang has been devoted in the packaging of for food and products and medical products, and Chairman Zhang is also promoting the business model for internal or circular or closed loop. For closed loop, especially for food container, can you share with us your experience, please? Chairman Xiao, panelists, participants online, good morning, everyone. For internal circulation, in recent years, just like what Mr. Su just mentioned, because of the issue of carbon emission and the carbon footprint, the production cost is increasing. For example, we buy PCR, the cost is now more expensive than virgin material. However, this planet, because now of the global warming, people are paying a lot of attention to recycling and the carbon emission. We know that for plastic material, this is the kind of material that is durable. It's a material that is durable, and it's light weight, and it has a wide variety of applications in every aspect in our life. And for our company, we produce clean packaging, clean product packaging, and the food packaging. We work together with the one of our customer. They sell their milk bottle, and they are encouraging their customers, once they the product is finished, the milk bottle can be returned, recycled, and then reproduced and become the material to be the package for other products. Because for food packaging, you can only use virgin material. But once we recycle these food packaging and we use it to produce the materials for the packaging for other products, and that is a good approach. However, how to recycle that, the recycling process posed a lot of cost, and that is the issue faced by another customer. For example, if they ask the consumers to send back the post-consumer products, the transportation and the carbon emission generated during the transportation process, that is also an issue. So we need to work together and to find a way to promote circular economy. The second product we have is for food packaging. And the reason why we have this product is because for us, as plastic material vendor, we have the responsibility to provide good quality products to our consumers. In early days, there are wide variety of plastic products, so we don't really have a good knowledge. So the plastic materials, it might contain plasticides or heavy metals, and if we use those materials and to do food packaging, it's not going to be good, or it's not suitable. And for food, and because there are other requirements, and there might be other contamination generated in the process. So we use the FDA standard and to produce food utensils. And we know that for plastic recycling, there are 7 types, and the 7th type is others. And we know that type 1, number 2, and that they have a specific material, but for others, type 7 is others, and the results of these materials classified as others, probably they'll be incinerated. So we are trying to build a mechanism. So for these used utensils, food utensils, and we can collect them, recycle them, and come back to our company, and we can reuse these materials and to produce, for example, soap cases or the racks for mobile phones. So we already recycled 800 kilos of these materials and use them as the raw materials to make soap cases. So for circular economy, we need the participation from all the consumers. If all the consumers are engaged, it is easier for us to achieve circular economy. And we also need the regulatory mechanism to help us. And otherwise, these recycled materials might end up in the incinerator. And for the recycling process, of course, sometimes it's time consuming. So if all the consumers understand their role they can play in and helping or saving the planet. And then let's do recycle all together. Just like Mr. said, plastic is a very stable material. It can be recycled multiple times. We can work together and save the planet. Thank you.
Thank you very much, Chairman Chen. He mentioned that in different areas, when implementing circular economy, they may face regulatory issues because when it comes to recycling the industrial products or food packaging products, as long as the customers are fine with the quality, then that should be fine. But if the recycled rubber or plastics are used for food packaging, then they are subjected to regulatory constraint because we need to follow the laws and certification. So as far as I know, in Taiwan's rPET, recycled PET, is doing very well. We have good recycling system and technology. So here in Taiwan, our government has also joined with the manufacturers. So the rPET, recycled PET, through some certified processes, the materials can be used for food packaging, that is from bottle to bottle. So from the food packaging bottles or materials, they can be recycled and then remade into food packaging as well. So when we're talking about the trends of circular economy for rubber and plastics, for example, we have large companies. So some big companies have started to enact their recycling policies. So all of the suppliers in the supply chain have to follow their policies. I know that probably by 2030, their global PET bottles from Coca-Cola, half of them have to use the rPET materials. I just want to stress that recycling economy is not just about lowering the costs. It's a matter of survival. If you do not follow this trend, if you do not follow in the footsteps of these big companies, probably your upstream buyers may just kick you out of the supply chain. It's not a matter of cost. It's a matter of survival. So I think this is the trend we have to follow and value. So in the second round of questions, I have some more questions for our panelists. So based on our sharing, I have some more questions. I think in the second round, do you have any conclusion or suggestions from our participants online? So I would like to start with Managing Director Che from BASF Taiwan. Any suggestions for our participants online? My apologies. Could you please complete your question? Well, because we have so much discussion on circular economy. So in the final round, could you please spend 2 minutes giving us your final recommendations?
Okay, thank you for the translation. Yeah, I think as many of the key points have already been mentioned by many of the guest speakers and also participants or moderators, circular economy has to be done collectively. I think this is no doubt about it, because you really need the inputs and the collaboration of all the individual value chain players in order to make it happen and to make it successful. So I think if it's only one specific, segments of the industry who are doing this, and if ultimately the consumer's behavior is also not, in line following, this direction, then basically we will never be complete. Yeah, it's all very similar to our COVID-19 situation. If the whole world population do not really collectively do the right things, then you will always have this virus still floating around and hindering us. Therefore, I would encourage, that we have everybody to remember this. We only have one planet. Resources are finite, is limited. So we need to continuously be responsible for our next generations. And we have to do the right thing. And the call for action actually has already been done. Or if it's not, have not begun, better start now. Yeah, it's better late than never do it. Yeah, thank you very much.
好，谢谢我们谢总的这个很重要的观。
Thank you for sharing this important concept. Circular economy is the responsibility of everyone. It's not just a responsibility of one company or one country. In Africa, people say that if you want to go fast, go alone. If you want to go far, go together. So I think that echoes to what Managing Director Che said. So I think this is a very important reminder. Thank you very much. If I have more time, well, we have a lot of questions from our participants online. So if we still have more time, then I would like to go back to you to have more questions. So from LCY, Commercial Director Sue, could you please spend 2 minutes giving us some final words? Circular economy has been a very important topic. With the rise of climate change and extreme weather events, now people are attaching greater importance to carbon reduction and energy conservation. So we see the change in carbon rights. So we also see the change in a value chain in the industry. So we see our peers should pay more attention to this regard. Whether you're in the PRC field or post-consumer products, actually, you can reduce 2/3 of the energy if you use recycled materials. In the past, people didn't really do the calculation. But if you start doing the calculation, if you calculate the cost for recycling, actually, your company will be more competitive. We know that still, although the recycling materials cost more than the virgin materials, but in the long run, it's still more competitive. So if we do a better job at sorting, I think that will be the key for circular economy. We don't just want to recycle and use it elsewhere. We want to use the recycled material, and want to put it back to the loop. So I think circular economy will only gain greater importance in the future, and that's the key to survival. Thank you very much. Mr. Su, there are 2 points from his remarks. First, we need to put great emphasis on carbon. I think it has been an explosive topic recently, wherever you are. If you want to join the rubber or plastic industry, definitely you will face the problem of carbon tax. So this will be a common issue faced by countries in the world, and people are enacting the carbon fee or carbon tax in a global community. And secondly, recycling rubber or plastic, our ultimate goal is not to downgrade the recycling. We don't want to downgrade the products, but we want to keep their original use or even upgrade the materials. To do that, it's not just about sorting. It's not just about mechanical recycling. We need to improve the technology. Also, Managing Director Che talked about chemical recycling. We need to create new features or characteristics for the materials. Finally, Chairman Chan, please spend 2 minutes providing your suggestions to our online participants. We talked about a circulation. We have been thinking about reducing plastics. Sometimes our consumers have some misunderstanding. They thought, well, we have a plastic bag. If I want to make it thinner, lighter, then that shows the reduction of plastics. So probably that will only be a single-use product and it breaks down very easily. But if we can maintain the durability of the plastic bag, but it can be reused 10 times or 20 times, then probably I think that is more in line with the concept of circular economy. I think this is a reflection. This might not be accurate, but we can have some reflection. What is the right way for plastic reduction? People have been talking about like coffee grounds or sugarcane grounds to replace plastics. We can reduce the use of plastics. I think that's a great idea, but we don't want to use corn, like starch-based products, because human and animals will be fighting for food. But if we use waste agricultural products like coffee grounds to create products for daily use, then I think that's a great idea. And when talking about marine litter, the total amount of virgin materials, if we can have a total amount control, and from the used marine litter, if we can extract materials from marine litter and create new plastics, and I think that will be conducive to the overall plastic reduction. I think we have seen a lot of news reports. For example, we have made shoes or some functional fabrics. The materials are extracted from marine litter. I think these will be our future targets, and we have starting to see the results. Thank you very much.
另外一个
Thank you. Chairman Chan also mentioned about one very important topic, that is the waste, plastic waste in the ocean. So in our organization, we established the Sustainable Material Library, and we collected hundreds of sustainable materials in the library. And one type is the material we have is waste in the ocean. I can give you one example. In the past, there were a lot of fishing nets, especially for the deep ocean fishing. And we understood that one fishing net is 14, it can weigh for 40 tons and using nylon, material like nylon. And for such a heavy fishing net, if there was any problem happen during the fishing process, what they did was that they just tossed the fishing net in the ocean, because if they carry these heavy fishing net back, it's going to consume their fuel. So that was a problem bringing a lot of people headache. And because now people are talking about circular economy, and now more and more attention to how we can collect these ocean waste and then make them new materials. So in our library, we exhibited, for example, our wasted fishing net, and or some the oyster shells. For example, once we collect the oyster shells and we grind them and mix them with other materials, we can make them yarn. So we can, if you're interested in these materials, you can come to our websites, and we established this library. And if you're a user, you're looking for a recycled materials, plastic or rubber materials, and if you're a supplier and a player in this industry, you can come to our websites and to look for useful information. And if you have good recycled materials, or if you already have very good materials, and you can join us, and you can exhibit your material here in the library so other users can find you. So for this library, we hope that it can complement this supply chain, so people who have the need or who already have something to offer, and you can join our platform. Now it's for free, so of course you're more than welcome to join us. We have received a lot of questions from our online participants. However, we only have a few minutes, so I picked some questions. And number one, the handheld IR device, people are very interested in that. And the question is that if the material is not transparent, or it's undyed plastics, or it's a material that has multiple plastic materials in there, can they be identified by this handheld device?
Much for the question and also for the interest in this high-tech stuff. But I have to declare, I'm not an expert in this product or this technology. But based on my simple understanding today, it can be used to scan the very common plastics that we have heard, polystyrene, PET, PC, PVC, all this. But when your question is about if it's a very mixed plastic, how would you be able to determine its composition? Now, I think scientifically, because it used near infrared, using infrared to identify the characteristics, of the properties of the material. So I think by scanning it and sending the data to our data, cloud database to do the analysis, rightfully it should be able to then tell us, after a few seconds, to the results. So how much composition, how much percentage is of this material A, second material B, and so on. And also, I remember in the demonstration that I have seen, it also gives us the percentage of confidence of this proportion. But for more specific, explanation on this, I would really need to also get, our experts, technical experts, to be able to address your concern. Please feel free to write to us your inquiries. We'll make sure we'll get back to you accordingly.
好，谢谢这个我们。
Thank you very much for your answer. So if you're interested in knowing more details about this device, and you can send your inquiry and contact BASF offline. And according to what Mr. She just said, I believe that because for IR, it is if it's a dyed plastic or it is not transparent, I believe it can be identified.
Correct. With the different colors, it's not an issue. Yeah, because as you mentioned, using IR, to determine the properties of the material.
是，对，所以
Yes, for complex materials, of course, I think it can be identified, and it can tell the device probably can tell you how many different materials, different types of plastics are used, and I think this is going to be helpful in terms of recycling process. It's very convenient, and that you can identify the materials very quickly. And so a great interest for this device. Thank you for your answer. And another question for NX8000. Question for NX8000, and our participants are very interested in knowing whether these additives can be used for medical products, because for medical products there are regulatory there are regulation issues. For example, ISO 10093, and so is it can this satisfy the requirement for sterilization, for example? Yes, for medical products, if any additives, it needs to be tested very stringently. So for NX8000, currently it is not used for medical products because there are a lot of tests need to be done, for example, sensitivity tests, for example. So now it is not used for medical products. Yes, for medical devices, it's more complicated. So we need to know more information. For example, what kind of medical devices, and you need the NX8000, and we need more information. So if you're interested, you can contact Mr. Su, or you can contact Milliken and to get more information. Okay. We only have 2 minutes more, so very briefly, I'll wrap up the discussion. So first of all, I would like to thank 3 panelists very experienced experts in the industry. We will really appreciate that you share with us your abundant experience and valuable insights, especially your views about circular economy. And I would like to thank all the online participants. Yesterday, I was notified that there are more than 500 people. There will be more than 500 people joining us. And we do hope that you find this morning session rewarding. So that concludes the morning session. Thank you. Thank you very much. And I thank all the participants. And that concludes the morning session. And in the afternoon, we're going to hear more about the medical and the transportation applications. Our afternoon session will begin at 1:10. 1:10. Thank you. We'll see you in the afternoon.
Distinguished guests, ladies and gentlemen, good afternoon. I am Li Zhao. Welcome back to the Plastics and Rubber Industry Trends Forum online, organized by the Bureau of Foreign Trade, BOFT, MOEA, and executed by TITRA and Plastics Industry Development Center. In the morning, we talked about circular economy for plastics and rubber. And in the afternoon, we will move on to the development and trends and opportunities on the topics of plastics on the move and medical magic by plastics. For the session on plastics on the move, our first speaker is Chief Technology Officer of Chen Xiong Group, Mr. Johnny Chen. He will talk about electric vehicle and plastic industry. Please welcome Mr. Chen. Good afternoon, ladies and gentlemen. My name is Johnny Chen. I'm the Chief Technology Officer of Chen Xiong Group. I've been working in this field for 42 years. And I have 39 years of experience in injection molding machine. I'm very honored to be invited to join this important conference. So when we talk about IMM, injection molding machine, it has over 60 years of experience. So with the rising demand in our daily lives, as we move on, we have seen the growing development. When talking about the EV, electric vehicle, and plastic industries, what are the connections? First, we know that electric vehicle relies on power. The output of power requires energy. So our purpose is to make the vehicles go faster and quicker. So the design of the vehicle, weight reduction is a very important topic and objective. So more broadly, transportation vehicles want to meet this kind of characteristics. And there are a wide range of transportation vehicles like those in the air, land, or at sea. They all belong to the category of transportation vehicles. From the scientific perspective, simply put, we know that F equals m times a. Force equals mass times acceleration. If we want to move a heavy item, we need to have the great force to move it. And this force, or the push, is generated by the generator. So the power of the generator, or the speed of the generator, is related to the size of the item. Regarding the power of batteries, if we do not increase the power of the batteries, what we can do is that we need to reduce the weight of the vehicle. So this is the main topic I will talk about today. Next, if I work in this field, if I am a car manufacturer, how can I win the recognition from our competitors? How can I make my product to be sold widely? Of course, I need to reduce weight. This is a very important topic. So when we talk about cars, we have different systems. First, we have the chassis system. We have the frame, power system, power supply system, wheel system, transmission mechanism, and so on. Can we reduce the weight of the chassis system? I think the engineers have to think about it. Secondly, the body of the vehicle. Inside the body, we have the sheet metal on the outside, the doors, the bumpers in the front and the back, and the windshield. So all these fall into the category of the body. The third one is the interior, which includes the dashboard, the seat, control mechanisms, and computer, and so on. And the other area, when we drive in a car, we want to put some accessories, or we want to make the car look beautiful. We have a lot of ornaments. Or in order to ensure the safety of the driver and the passenger, we have designed all kinds of safety system or security system. Or we want to listen to the music, so we want to have the audio or entertainment system. All these combined. How can we reduce the weight of the vehicle? Can we do that?
As a car designer or manufacturer, this is the issue we have to think about. So car weight reduction. There are 3 objectives. Number 1, selection of alternative materials. We used steel, or we use a large portion of copper in manufacturing our car before. Can I use materials with lighter weight? Yes, of course you can. Number 2, if I have to use heavyweight material, can we make the parts lighter? And if I want to achieve a lighter parts, what approach can I take? This is the issue faced by industrial designer and manufacturer. Number 3, we take a look at our car and to see whether there are anything that is not necessary. Can we remove this? Can we eliminate that? Because if we have anything that doesn't have the function and we do not want to remove it, and the consequence of that is you have extra weight. So all these weight will consume the energy, the power from your battery. So a lot of the power will be consumed by these unnecessary parts, and of course that will affect the distance your car, electric car, can run. Now we're transferring from the traditional fossil fuel car to electric car, and a lot of people have this concern. What if I run out of battery in the middle of the road? And of course, if I am going to take one long distance journey, of course you put this calculate how many miles or kilometers we can drive, and now is the only thing different is that now we're driving an electric car, and now it's the battery that is driving the car. And if we, according to our calculation, and we just have to make sure that if one-day trip, we don't have to recharge the battery for a one-day trip. And there are ways to do that. You either reduce the weight of the parts or you reduce the weight of the body. We talked about using alternative materials. So that will bring a lot of changes. Alternative materials, for example, in traditional transportation, traditionally, we use a lot of metals to build our transportation vehicles. For example, iron, copper, and aluminum. We believe that these are the metals, especially steel is the major material we use to build a car. So which one is heavier? Of course, for copper, copper is heavier than iron, than steel. And so what other material, what alternative material we can use to replace copper? And that is the thing we have to think about. For iron, 7.6, meaning that 1 liter of iron, it weighed 7.6 kilos. So we think about this. We started to see that some vehicle manufacturers use aluminum alloy to replace steel or titanium alloy to replace steel. And of course, aluminum is lighter and titanium is slightly heavier. And so people also think about plastic. So before plastic was invented, all the vehicles were made by metal. Now we're in the 21st century with technology advances. Now, even we use the car that use fossil fuels. A lot of cars are using plastics in the parts, and the plastic is 7 times lighter than steel. So at least 15 years ago, people already started to use a lot of plastics to build parts in the vehicles. However, in early time, probably people only use plastics in some interior parts. And gradually, we started to see some composite, meaning that a lot of different materials were used and to build one material. And in a lot of the traits, the qualities of the materials were changed during the processing period. And as a machine builder, a machine maker, of course, because a vehicle is a machine, and we are machine builders, so we can think, come up with a lot of ideas of applications. If we use metal, and we have to cut, we have to forge, and we have to do a lot of processing to the metal. And that in the processing, metal processing, of course, it consumes a lot of energy. If we use alloyed, aluminum or titanium alloyed, the processing we used to use, we cut, and now we press the metal and to extrude or to press the metal. And we don't have to use the cutting process. So on top of weight reduction, if we change the processing approach, we can reduce a lot of energy consumption. And if we use plastics, we make mold, and we use the injection molding approach. So at early days, if we for bumper, if we use metal material, there are a lot of different steps. We have to process the metal, and maybe we need to use 1 hour to process the metal to make a bumper. And if we use plastic injection molding approach, basically we only will only take 3 to 5 minutes. So in terms of energy consumption and in terms of capacity and output rate, and it's even better compared to traditional cutting approach. Injection molding approach, the people may have concern. Number one, the mechanical nature of the plastics, it's limited. It's a terminology. It means that the strength for impact strength or the resistance, etc. So people do have concern about these strengths. So if this part need to bear the impact, the shear force, etc., and the plastic simply is not strong enough. And that is why we started to see composite. So now we have the composite material, mainly made of fiber and the plastics. So in early days, we have the short fiber, but now we know that carbon fiber is now used in the composite approach. If carbon fiber is so good, why do we see very little progress? It's because in the composite processing of carbon composite material, there are still a lot of technical issues need to be overcome. Of course, when there is an issue, it means that there stands opportunity. Otherwise, everybody can do that. So as we are machine builders, we are machine builders in the plastic machinery field. Of course, we see where the problems are and we see where the opportunities are. We see there are different materials, so we can have different processing approach. And if we change the processing approach, of course, they will bring an overwhelming impact to the industry. Because if the function can be provided by injection molding machine, for example, and some of the machines, the traditional machines, will be replaced. So the industry will change. So the cost is also changed. We know that metal, starting from mining, the refining, and the processing, it has to go through a lot of different processing steps. It consumes a lot of energy. If we have 1 ton of steel, 1 liter of steel, we have to consume a lot of energy. And for metal, even if we can recycle metal, we still have to melt it. So if we want to melt the steel, the temperature is 1,300 Celsius. And just imagine how long do we have to heat it and how much energy we have to consume. And of course, for plastics, it consumes energy in the processing. And however, in the process of recycling and the reuse of plastics, it consumes relatively lower energy compared to metal. So this is how we see the issue of energy consumption. Of course, we see there is an overall change in the industry. For metal, we see there are different processing ways. And if we use plastics, injection molding And there are two completely different fields, and there's two different industries and the different experts and the different investors. So, and they will bring a big impact to the industry. It's not that, okay, we used metal before and now we use plastic parts. No, it's not like that. The two industries will be affected because of that, because you change the material to build your parts.
So we talk about the change of the materials. Moving on. If we cannot change the materials, what else can we do? Of course, for the existing parts, I can try to make them lighter. So I will need even more precise structural design, which can endure the shear force. We can make sure that it has enough durability. If we only follow the past design experience, then problems may occur. With the rise of scientific development, we have seen the transformation of the industries. So now we can use the CAE for further assistance. CAE is the computer-aided engineering. So CAE can help us with precise analysis and design so we can clearly find out what else can we do, which kind of materials can be removed. So that is how we can remove a weight or lighten the weight of the materials. But what about plastics? Can we make the plastic materials even lighter? Like what we do with the metal materials? We can try to remove the redundant materials, or in the plastics, we can use the foamed materials. Foaming means that we can use Polaroid or we can use other materials. They're soft, there are pores inside. When we use the foaming materials, then we can try to reduce the weight of the plastics. I just want to tell you that some people are studying the foamed materials. I've read some literature, but I haven't seen that. But I know some people are working in this field. So the foamed materials can be used not only in plastics, but also in metal, probably in the future. Moving on, we can use the composite materials. The main ingredients of the composite materials include the adhesives and the plastics, but the pressure resistance of composite materials is much lower. For 1 square kilometer, it only has 900 kilometers, but for alloy, it can be 98,000 kilometers, so 5 times of difference. But the weight of plastics is only 1/7 of metal. So for a designer, for an engineer, how to make the best choice? With the rise of composite materials, we need to strike a balance. We need to weigh in all of the weights of different materials. You need to have an overall evaluation, and also by capitalizing on the characteristics of different materials. For example, in plastics, we can add some filling material. In the past, people use glass fiber or carbon fiber, mostly glass fiber, but now we use carbon fiber. We know that if we cut off the carbon fiber, then they do not work so well. So we need to have very long carbon fiber to toil it up so that we can use it. By using the adhesive to cure the carbon fiber, so that's the better solution. For a lot of airplane companies, we know that some parts of the airplanes have been made lighter. That is, we use carbon fiber and adhesive to make the materials lighter. Usually, the adhesive is about 1.9 or 2, which is about the same weight as magnesium alloy. But the extraction of magnesium alloy is related to its overall deposit in the world. So the cost of magnesium alloy is very high. The technology of carbon fiber technology is now be made automatic, so it is quite cheap to make carbon fiber. But if we want to make it into a composite material, I think there is still a long way to go. There is still great improvement to be made. Also, by removing the unnecessary or redundant parts, I think there are some suggestions. The first is that we can remove the unused parts. Probably the part is already obsolete. For example, the audio or the video equipment. In the past, it was a huge stereo machine, but now the audio player is about the size of a finger. So we have to think about what kind of parts are obsolete. We can just remove them. Secondly, we can simplify the structure. Some of the parts are over-designed. I think the designers maybe overthink the function of the product. It has multiple functions, but they may not be so useful. When we are driving in a car, do we really need to use all of these functions? We can think further whether we really need them, because if we cut down 1 kilogram, then our car can go much further. So these are the solutions. We can remove the unused parts. We can also simplify the structure. So far, I have put forth the objectives for weight reduction. Some of you may ask whether it's a automobile or motorcycle when it comes to plastic injection molding. What can we do with it? Please allow me to give you some brief introduction. So the IMM, if we do not change how it works, we have large and small IMMs. So I think if it's bigger, so for the IMM, we have to see that maybe probably we have 30 tons to 10,000 tons of the force in my company. So we have like all different sizes. So we have all kinds of structures. So if we're going to make the sheet metal, the doors or the bumpers, all these are large items. So we can look at it. We can look at the size, we can look at the appearances. All these are the two major parameters. So we can use 850 to 2,200 tons of the machine. If we want to use the IMM to create a frame, then we need the injection molding machine with 3,000 to 6,500 tons. If we want to use IMM to make the whole frame, then of course we can reduce a lot of weight. But because the frame has to reduce a lot of tensile stress, then probably I think we can use carbon fiber to help make the frame. I talk about carbon fiber. I think there are two issues. First, we can use the thermoplastics materials. And second, we can use the thermal curing adhesive. I think they have different functions. And currently, people are using both ways. So, as mentioned before, we need to think about the mold clamping force. And I believe that we can make further breakthroughs in the future. In the vehicle, we have some small parts, for example, some buttons on the dashboards. Then we can use the small IMM to create the parts. So I think the IMM machine with 120 to 700 tons will be suitable. We also have multiple lamps. So now I'm focusing on the rear lamps because the rear lamps will be multicolor. So we have red and yellow and also other colors. So for the rear lamps for cars all over the world may come in these colors. So we need to use the multicolor IMM. So we can create 3 colors in one machine at one time together. If we want to reduce the weight, then now we can use the foaming technology. So we have the chemical and the physical foaming technology. They have different functions. So we also have different safety concerns. Mostly in the cars, we use the physical mucil or a foaming technology because if we use the chemical method, there may be chemical residues and that may be harmful to human bodies. So chemical mucil technology has been banned. So now we are promoting the physical mucil or foaming technology. For physical mucil technology, I think so far we already have a very solid ground. Now, moving on, reinforcement. If we cannot change the plastic material, then we can use glass fiber or carbon fiber embedded in the injection technology. So we can use the traditional injection molding for the composite materials. We can only use thermoplastic materials. Thermoplastic materials now in the industry. Now people want to make improvements in the technology. That is, we want to use injection molding to strengthen the composite materials. And for the complicated structured parts, we can also use powder injection. That's also one way of injection molding. We need to go through some other processes. For example, sintering. Sintering is a very common method used by the industry. Many people may not be so familiar with the IMM. Maybe you have never seen or heard of it. But because we are in this industry, so I think all of the participants online, I think you should know the IMM machines quite well. On the screen, you can see this is a 6,500 ton IMM. It's called the dual platen injection molding machine. You can see the size of it compared to the human. So this is quite a big machine. So this is an insert molding machine. So we have the machine over here. So you can take a look. I won't go into the details. As for the lamps, in order to reduce the processing technology and to shorten or to reduce the energy consumption. So now we use the multicolor injection machine. We can use the multiple color injection molding machine. So for the tricolor light, we can create one mold. The benefit is that all these can be done in one step. We can reduce the yield rate. We can improve the yield rate, and we can also use the bicolor or tricolor light. We can use the foaming technology. So this has the anti-impact effect. So I think probably we can use the tricolor or multicolor IMM. Now we are talking about the mucil technology. As you can see from the slide, This shows chemical foaming. That is, we can use nitrogen or CO2, these kind of gases in the air. So we can use them to be the agent for foaming. And for chemical foaming, that is, we use chemicals to lead to foaming. As mentioned before, due to the problem of residue, chemical residues may be harmful to human bodies. So for the plastics used in our daily lives, we rarely use chemical foaming in these products. We are still developing the physical foaming technology, and so far we have seen some developments. During my years in this industry, we have successfully helped some of our clients to create some successful cases and machines, and they are able to function properly so far.
I also mentioned about fiber insertion. In the picture, you can see the picture of our trial product. So you can see the grid, it is carbon fiber. So it is woven into fabric and then being inserted. And then we use injection molding technology. But you can see the hole. And in the hole, you know that the carbon fiber was cut. So for any hole, we know that we need to use a bolt or a screw. So the function for the carbon fiber to transmit energy is also sabotaged. Because the objective of inserting carbon fiber is to strengthen the material. However, you drill a hole, and so that the strength is also affected. So this is something that we have to resolve. And next one is liquid materials injection molding technology. Silicon is the material that is often used. And if we use the heat-cured material, and then we just have to use different approach. And now this approach is pretty much matured, and that it still has great room for improvement. Next, powder injection. A lot of metal materials. We have to cut a lot of unwanted part, and if we use powder injection molding, and probably we don't have to cut so much, meaning that the part that we have to cut off is less than 1%, meaning that with powder injection, the completion to the final products, how close it is 99%, meaning that we only have to cut 1% off. So they can greatly increase our output. So we can greatly reduce the energy consumed in the processing period. In our industry, including machine builders, including users, including other manufacturers, we can all together, we can think about how we can design the manufacturing process that can consume less energy, and how we can create facility with greater output and a greater output capacity. Number 3, composite material. Now, a lot of times the composite materials the processing steps, a lot of them is a lot of manual work in between, and we want to automate it. How can we make it happen? And we have to work across different industries, and to make a very complicated parts, and maybe we based on our working with different industries, we can create one processing approach, and so that we can make the parts more easily. And also we want to make the machine more durable. And if we can use the machine for more 3 years longer, it means that it's going to help the planet. We're going to consume less energy. Thank you. That concludes my presentation. Thank you very much. Thank you for your presentation. And next, and please welcome Dr. Huang Chuangeng, Senior Research Chemist of Internal Materials. He will talk about lightweight applications of thermoplastic composite. Please welcome Dr. Huang. Good afternoon, distinguished guests, ladies and gentlemen, participants online. Good afternoon. I'm delighted to have this opportunity to talk to you the development we have achieved for thermoplastic composites for lightweight applications from internal materials. We heard from Mr. Chen and also the speakers in the morning session about how everybody is working and contributes their part to help the planet and to reduce the harm we do to our planet. We heard about how we reduce the weight in transportation, vehicles making, and also the changes we bring to our materials. So today, I will briefly talk about from the perspective this topic from the perspective of composite materials. But composite materials is not something new. In Taiwan, we've been using the heat cure composite materials for a long time. And we already see how durable it is. And so today, if we can use thermoplastic composites and to make sure that it is more durable, and it is possible that we can have more applications. And we can widen its applications, even to use it to replace metals or other composites, so that we can make our products lighter and more environmental friendly. Very briefly, I'll introduce myself. My name is Huang Chuangeng. After graduation, I've been working in internal materials. It's been 7 years since I joined the company. This is the outline of my talk. So I'll briefly mention the development trend of thermoplastic composites and the effect it brings to the industry. So for thermocomposites, one thing that has a technical difficulty is that it's difficult to process. So how do we overcome this difficulty? And in room temperature, it's solid. And how do we process it and to combine these composites with fiber? And this is something that we have to, this is the technical issue we have to overcome. Fortunately, in the past few years, we've had some advances in molding technologies, and we see some improvements in the fiber material. So we started to see good connections or some improvements of the material themselves. So internationally or in Taiwan, we started to see a lot of thermoplastic composites appearing in the market. because for thermoplastic composites, it doesn't have a chemical reflection, so it's mainly mechanical nature. So, and it's easy to process. It's fast, and so it consumes less energy, and consequently, the cost is lower. And for this thermoplastic composites, a lot of them can be recycled, just like what we heard in the morning session. And if we include the carbon tax, the cost of carbon tax, a lot of times the virgin material can be more expensive. So the recycled material becomes very important, and that is why thermoplastic composites has become a mainstream, and that is one of the reasons why. And I will also mention that for common thermoplastic composites and how do we use them, and normally we see that they're used in the form of LFT. It can be injected, and also we see the application of UD tape. And for eternal materials, we also have developed variety of thermoplastic composites. And these materials can work together with fiber. And because we focus more on so for these materials, once it is formed, the shrinkage rate is low, and we can use the structure adhesive or the adhesive you find in the market. These adhesive can work together with our composites, thermoplastic composites. And lastly, I will also mention about some application examples. So let's take a look at this slide. So just like I said, thermoplastic composites is not something new, and we started to see it period in the 1970s, and then in the 1990s we started to see these materials being used in bicycles or buildings, and then after 2000 we see these used in the field of for example, wind farm, etc. And we see for these materials, and one of the issue we had is the recycling process. So people started to think that maybe we have to make some changes to the material themselves. And that is when we started to see some changes happening to the thermoplastic composites. Especially in composites, we see the applications of composites. It is used in aerospace or are used in the transportation products. So we see a very clear trend of a CAGR growth. Every year, the CAGR is about 7 to 8%. With 7 to 8% CAGR, no matter is thermoplastic composites or heat cure composites, together the CAGR can reach 8.8%. In the process, we can also see from the JEC statistics. In the past, thermal set is dominant in the market, but in recent years, we started to see the orange part, which represents the thermoplastic composites. So overall, of course, the thermal set and the thermoplastic, both of them are growing, but we see now the orange part is getting a bigger ratio, and there is a reason for that. For example, it has better impact resistance, short molding cycle. It's easy to store. Unlike thermal set, it needs to be stored in lower temperature, and for thermoplastic, it can be stored in room temperature as long as you keep a good storage condition.
Also, we can reduce the time for manufacturing, so we can cut down the cost. Also, we are able to recycle the waste, so we are able to reduce the cost for raw materials. And because of the recyclability, so thermoplastics are actually a environmental friendly material. So they can come in the SFT or LFT or UD or forms of the fabrics. So these are the common forms of thermoplastics. So over here, as you can see, let's take a look at the fiber length compared to the mechanical properties. The longer the fiber, then the stronger the material is. So from here, you can see inside the blue box, you can see the common semi-products from thermoplastics. We have the short fiber and long fibers. The length is usually about 100 to 1,000. Basically, to reinforce the strength of the product, we can use the unidirectional filament reinforcement. That is the UD tape. So I will also introduce the differences between these different materials. So we can see the growth of composites. So in terms of LFT, overall, you can see the CAGR can reach 7 to 8%. So here in the market, people still use PP or PA or nylon. Later, I will also explain how Eternal Materials can differentiate ourselves from other competitors. When we use these kind of materials, they're all very clean. So it's not easy to use the coating on top of it. And this is also a problem of lack of interconnectivity in terms of the use of the products. But why do we still use the LFT? In the past, we see that SFT was widely used in the market. But as more and more people start to see the deficiency of SFT, then people started want to increase the strength of the product. So over the past 1 or 2 decades, because we want to make improvements in the technology for SFT, also people started to develop the technology for LFT. The fiber strength is about 5 to 20 millimeters. Compared to the SFT's only 4 millimeters, we can see LFT's fiber length is about 5 times higher than that of SFT. And in the injection, I think we can have more than 1 millimeters of retained fiber length. Because the retained fiber length is longer for LFT, then it's easier to interweave the LFT, so we can create a 3-dimensional product. So the strength of LFT is also better. Let me show you a video. So you can see this is a video from Plastic Comp. This is a product of SFT. So you can see the truck running over it and it's broken down. And this is a product from LFT. This is from carbon fiber reinforced product. So even the truck runs over it, it will not break down. So when the fiber strength is longer, then it is stronger. You can see the fan made of SFT. If it's knocked down by metal, then it will break down. But for the product made of LFT, then it can have good energy transmission. So it will not break down, even though it's hit by a metal. And by using metal, you can see the metal products are heavier. But if we use the reinforced composite from carbon fiber, the weight is only about less than 1/3 of the metal material. So that is the reason why over the past few years, the composite materials are booming. This is because we want the materials with better strength can be introduced to the industry so that we can use lighter materials to help the industry to improve the overall weight of the products and achieve carbon reduction. So in terms of the potential of composite materials on the left, the SFT material, the strength is in the pink circle. For reinforced LFT, it falls into the green circle. And it covers a wide range of strengths. If you use the appropriate fiber length and the proper materials, actually we're able to reach wider length. The blue circle shows the continuous fibers strength. Actually, it's almost the same as the strength as metal. So, if we can find the right composite for the product, then we're able to use the composite material to replace metals in the future. So, when we look at the SFT or LFT, you can see the strength. When we see the percentage of the glass fiber to the strength, if it's about 40 to 50%, and I think that is really good. I think it's easy to understand. Inside a building, probably we need the steels, we need cement. It's impossible we have purely steel or cement, so we need to have the composite. So if we can find a right percentage and we have the right percentage of the fiber, then we can come up with the best product. Moving on. Among the composite materials, we can have the long carbon fiber and long glass fiber. So from here, you can see in terms of the glass fiber reinforcement materials, because the percentage of the glass fiber is higher than that of carbon fiber. So from the orange lines, it shows the change in density. When we use the products from the blue boxes, for example, if we want to use 60% of long fiber, then the strength is only about 150. But if we use 30% of the long carbon fiber, then the specific strength can exceed the previous one. And the density can range from 1.7 to 1.25. So once we use carbon fiber to reinforce the material, it is more likely to make the product stronger and lighter. So now, let's take a look at the LFT and how it's compared to the strength of the metal. So overall, LCF 50, PA 66. So you can see This is the LFT50 PA66. The strength is almost the same as the titanium and even higher than that of aluminum. So actually, it has a great chance to use the IMM on top of the LFT. So we can create a product by using the technology to replace metal. So maybe for some part of the vehicle, we can use this kind of material to replace metal. So we can use the LFT. By using injection molding, we can make the cars run faster with better quality. We can also cut down the cost for production, so we can see the reduction in the total cost. Also, UD tape is another common type of materials, whether it's SFT or LFT. They are actually non-continuous reinforcement material. So what does this continuous mean? When we are making the product, continuous fiber means that among the fibers, they are continuous, they are interconnected. So we can improve the strength of the products. But for the dis or non-continuous fibers, it means that in this product, the fibers are broken down, but they can be processed faster. But in a continuous fiber, the strength of the products is much higher. So UD tape contains continuous fiber. It's very easy to use. It's just like the duct tape. You can cut it into all kinds of shapes you want. Then we can use thermal pressing or thermal forming to create the forms you want. There are different kinds of applications for UD tapes. So we can put it into the shape you want, or for example, I can use the UD tape to reinforcement a special part of the product, or I want to create a special form by using the UD tape, then I can use the product. So I think thermal forming and thermal setting, what's the difference? In terms of thermal setting, it takes a certain pressure and temperature so that we can create the end products we want. But thermal plastic is different. So we're going to show you the laser-assisted fiber reinforced tape winding. As you can see, we have a robotic arm. Then you can see the laser machine is heating up the machine. Then we can use the wheel to add pressure on the cylinder. By winding and winding the tape, then we can create a thermal setting product. This is quite a new technology by using UD tape. So we can create a product with high strength. By using thermoplastic composite, there's another advantage. For example, we need to have complicated forming and strength. We need to have special design so the UD tape can be made into a very strong product and it can be embedded in the mold. Then we can use injection. So the LFT can wrap up the product so it can be highly complicated and it can be formed. That's another advantage of thermoplastic composite. So by adding pressure or temperature, we can change the forms of the material. In 2019, in the JEC exhibition in France, we can see some of the products there. We saw that on the left, Poly1, they use PP-LFT and PA-LFT to create the parts of a bicycle. And you can see Solvay, they use the products for the line. So Teijin create products or materials for aviation, and QSP use PEEK and UD plus LFT to create the window frame for airplane. And Tenkate use the hybrid molding to inject the sole of the shoe, and then they use the inject molding to create the lines inside the sole. So we have so many applications in terms of the thermal setting products. Correction, in terms of the thermoplastic products, they can be shaped into different forms and they can be used to create complicated products. For example, they can be integrated with metals or they can have over molded function. In a part, for example, we have JC winning example. For example, we have created a pipeline by putting it inside the IMN through certain pressure and temperature. The pipe can be pressed into the shape of a star, and then we can have the injection. So by molding the pipe through 2 steps, then the connectivity of the pipelines is even better. So we can have secondary processing to change the overall design so that the product can be better.
And now let's look at our development from my company, Eternal Material. In terms of glass fiber, we made some woven fabric pre-preg, and we can make it very, very thin from 0.16 to 0.4 mm, and these materials can be used for for sports and computer and communication products. And we mentioned about the LFT, and for our LFT materials, mainly we use a carbon fiber, and our product, the length is 12 mm, and it can be adjusted, diameter 2 to 3 mm, and the application is mainly for transportation, sports, and 3C products. And now we are also developing carbon fiber UD tape. And now the progress we have is that the width is about 150 to 300, and the thickness, I put 0.15 to 0.18, and actually we can make it thinner. And we have the technology to make it thinner, and the applications including transportation vehicle, sports, and the 3C products. So for thermoplastic polymer, and just like we said, it's it's a product with high polymer. So how can we make the material combine with the fiber? And the level of combination is very important. And at Eternal, basically we have the technology to adjust our own resin substrate, and we can make different modifier and for fibers, and so that we can boost the impregnation. So if the impregnation is poor, just like what we see on the left-hand side, we take LFT, for example, and you can see with poor impregnation, the coating fiber palette, it can also wrap on the outside and cannot really go inside the fiber. And if it's fully impregnated, and you can see the fiber is and with the long fiber palette, you can see the fiber is intertwined with the resin. And how do we make it happen? How do we make sure that these combination or the integration be better, no matter if you are a substrate vendor or a fiber vendor? So these are the technical objective we want to achieve. So here I would like to share with you our achievement. So for our fiber, after we modify them, and its bonding quality is better. We use this micro bond test to prove that. So microbond, we put the resin and the modified fiber together and to test its strength. And from the results we can see on the left-hand side, you see this is the normal carbon fiber without modification, but the strength is about 60. So once we modify it, and you can see the strength can be increased and to 75. So about 15% increase. And we use this as substrate and make sure that once we modify the fiber and we use the resin developed by ourselves, it's the bonding nature can be improved. And what we showed you was the micro bond. Probably we only see one single fiber. And I can show you another example from the perspective from cross-section. We want to make sure that the impregnation is being done properly. So we take one single LFT particle and we press the tip of the tweezer and to deform it, and then we check the impregnation state of matrix and the fiber with SEM. So from the picture, we see the LFT from external. We can see the fiber and the resin. The impregnation is very good. So it's fully impregnated. And on the bottom of the page, we see pictures of fiber from another company. If it's impregnated poorly, then you see that it's not really, it's not as good as our own fiber. So you can see clearly see the differences, and you can see the fiber is very clear that it's separated one by one. But for our the LFT particle, the impregnation is done in a better state. Now, for internal LFT, we have different types of materials. And we can see for room temperature, it's about 100 degrees, and for flame resistance, it's about 130, and the other types, it can be as high as 150 Celsius. And for room temperature LFT, you can see that performance, if compared to products from other companies, because we use the same injection molding machine. And so the comparison is justified. And if we look at the tensile strength, it's about 185 MPa. And if it's an PA6 LFT, it's about 171 MPa. So eternal LFT, from this table, we can see the tensile strength is not less. It's pretty good. And for the flexural strength, the eternal products is about 280, and for P company, it's from 298. So just like I said before, now we have three types. We have low water absorption, the flame resistant, and the water resistant type of product. So if we look at the strength, the tensile strength for the low water absorption type 185, flame resistant 150, and the water resistant 205. And before we use LFT, probably some of you have the experience using LFT material. When you use this material, one thing you have to put in mind is that we have to use a different screw and to inject, because we have to use a specific screw to make sure that the shear stress will not sabotage the nature of long fiber. On top of that, you can see the fiber strength distribution, and to see the length of the fiber. And if we use the right screw to do the injection molding, the length of the fiber is better. So basically, the average is 3 times more. So if we can keep the fiber longer, and of course we can make the product stronger. Because of the confidential issues, we won't be able to show you the products, but we can show you the application. So here, the LFT, and because after being injected, the dimension is very stable. So according to the feedback we receive from our client, the shrinkage rate is low, meaning that the products, they are the fiber is evenly distributed. So the torque force 6 Newton meter, and it's not easy to break, and it's low shrinkage, and we can use the adhesive acrylic or epoxy acrylic adhesive, and also it has the forging fiber flow, and some people quite like it. And by using the LFT material, and we can use an acrylic adhesive, or we can also use epoxy an adhesive. In this table, we see we use an epoxy adhesive EP125, and the strength can be 20 MPa. And if we use acrylic adhesive, the strength can be as strong as 18. And if we use the pull test, aluminum and LFT, and if we use the adhesive to combine these two, the strength can be 3. And so this is the major difference between our products and the other thermoplastic composites, meaning that our products can be, we can use the adhesive. And now we're also developing UD tape, and the quality of the UD tape, just like we mentioned before, we stress on the how well you can spread on the matrix. On the left-hand side, you can see if it's spread well, the thickness can be it can be thinner, and on the right-hand side, if the toe is not well spread, you can see the final result can be thicker. And we use ER9032 matrix, and you see the thickness is about 0.12 to 0.15. So the thickness, it's close to the thickness of the yarn itself. It means that the UD tape, it's spread well. It also means that the matrix and the fiber, and it's well mixed, and it's well combined. And here we can look at the strength between for fiber content. If it's 55%, and we can see the corresponding strength. And if it's the fiber content is 65, and then the tensile strength the corresponding tensile strength. We can see the numbers here on this table. I skipped some of the slides. So today, if we can apply this reinforced thermoplastic composites, we can really realize the possibility of the finished products lightweight in different industry, for example, in transportation and other industries, and we can realize reducing carbon emission. And they can be, for this material, it has the characteristics of fast-forming secondary processing and the reduction of total cost. And it's possible if you recycled well, we can really reduce the total cost. And for my company, we've been developing high impregnation LFT and the UD tape. So far, the biggest difference between our products and the other from other companies, we have low shrinkage rate and it is more stable and low water absorption. And for our material, it has the high bonding strength with normal epoxy or acrylic adhesive. So if we can apply these material in different markets, in different industries, it is possible that we can reduce the weight of various products. So that concludes my presentation. Thank you.
的分享，接下来我们将进入第3个主题：医疗创新应用。首先邀请到的是傅强新。
Now we're going to move on to session 3, Medical Magic by Plastics. Our next speaker is Director of the Field Application Engineering Center, FCS Group, Dr. Vincent Lin. He will talk about how smart manufacturing upgrades and certification of plastic medical parts injection molding. Our dear participants online, ladies and gentlemen, good afternoon. I'm Vincent Lin of FCS Group. So now I will talk about smart manufacturing upgrades the validation of medical injection molding. First, I'll introduce FCS. FCS was founded in 1974. We have 4 branches: Taiwan, Dongguan, Ningbo, and India. We have over 8,000 clients around the world. We use the key component parts like the tie bars made from IMM machine. From 1974, actually the total length of the tie bars produced by IMM is equivalent to 1,500 Taipei 101 towers. So this shows our product lines. So for the IMM, we have 60 to 4,000 tons of clamp force products. So we have a wide range of production lines. So we have the dual color or large plastic parts. Also, we have some machines producing medical devices. We also have some special machines and special machines for the special materials. So this is our product positioning. Over here you can see, based on the speed and the requirement of the precision, you can see a wide range of products from different product lines. And in the area of medical devices, our IMM are used for 100 to 300 in terms of the speed, which requires high speed. So we have the CTE machines and CTR dual color machines. So these are used for the products for medical products. They have to be quiet, clean, fast, and efficient. So you can see this is our deployment for our global network. So we have about 21 agents with 30 branch offices around the world. So in Taipei, we have Taipei, Taichung, and Tainan. We all have offices. And in Dongguan and Ningbo, we have about 21 offices and 4 agents. In addition to our presence in China, we also tap into Southeast Asia, Europe, North and South America. We have our offices there to provide our customers around the world the maintenance services around the world. In terms of the awards and certification around China, in terms of our sales, I think we are one of the top 7 IMM companies in China. So we have received 17 awards in Taiwan. We have received 9 awards from Taiwan Excellence, and we have obtained 19 new and invention patents. For example, the CE or NC certification or SGS certification, we have received all these certifications. So for FSC Group, in addition to IMMs, to consider the needs of our customers, we have provided a total solution or turnkey solution to our customers. In addition to the IMM or the molding machines and the technology or mass production and material technology, we have worked with many partners so that we can provide good technologies, and FSC provides the integration to provide the services to our customers so that we can expand the market and continue with innovation. And due to Industry 4.0, we have provided data analysis to our customers. So we have the IMF 4.0 solution, and I will talk about it later. Moving on, we know that due to the outbreak of COVID-19, so in our field, what are the opportunities and challenges? Regarding the opportunities because of COVID-19, so we have seen the rising demand for PPEs and life-saving equipment, testing equipment, and syringes, and so on. Due to COVID-19, we have seen the direct rise in the demand of these products. And also because of the outbreak of COVID-19, countries around the world have moved back to protectionism. So we have seen a restructuring of supply chain. Throughout the process, our partners in the region also want to seize this opportunity. So we have started to work with our international partners and to build trust. So that also presents a good opportunity. When we talk about the challenges, there are 3 aspects. The first is the lack of digital tools, because here in Taiwan, in terms of the injection molding machines for medical devices, I think our management is still lagging behind. In terms of the introduction of digital tools, I think we are still not doing enough. What's the problem? Because we're still relying on our past experience to resolve the IMM problems. We are not using digitalized data analysis to identify the problem and solve them. So this is indeed a big issue, and this is the challenge we have to overcome. Secondly, due to the prevention of the pandemic, so we have seen a shortage of manpower. So it's really difficult to have enough staff on site in a plant. So in terms of the automation, I think we're still lagging behind. On the right, you can see the statistics from the World Robotic Arms Association. In 2019, you can see the number of robotic arms. So we have about among 10,000 people, the average is about 113 robotic arms. And Singapore has the highest, followed by South Korea and Japan. The use of robots is the highest. And also in Germany, Germany ranks the 4th. So I believe that by automation and using robots, we can reduce the need for manpower. We can also make the products more consistent. So it's easier to help us achieve our goal. And the third issue is that in terms of the field of injection molding, I think we still lack the validation. We don't see the effective certification or validation process. So according to the GHTF, stipulates that we need to have process validation. What does process validation mean? That is to establish objective evidence to confirm that the certain manufacturing process is under a special control so that the process results can be guaranteed to meet the requirements. In general, the validation of process is that the manufacturer will use the process to plan, to obtain data, and to record data, and to interpret data. So the process, according to the guidelines of GHTF, it is called the 3Q. So IQ, OQ, and PQ. So the installation qualification and also operational qualification and also performance qualifications. So first, let's talk about the IQ under GHTF. According to IQ, that is, we need to use objective evidence to show that the process equipment and ancillary system of the installation adhere to the manufacturer's approved specification and the recommendations of the supplier of the equipment are suitably considered. Two problems arise. First, in terms of injection molding, when we choose the machine specification, we need to think about whether the product can meet the requirements of the size or the mold. We rarely think about stability. We rarely think about the specification of the machine. Secondly, throughout the operation process, no matter what kind of machine that is, as time goes by, we can see the wearing down of the machine, and this may lead to the reduction of the function. So we need to have regular inspection to make sure that our machine can still meet the demand. We need to make sure that they're running well, but we do lack this kind of inspection. So I think that is under the regulation of IQ. Moving on, operational qualification OQ. That is, we need to use objective evidence to control the limits and to have the action level, which will result in the product that meets all the predetermined requirements. Later, I'm going to explain what that means. So the 3Q guidelines can be applied to all kind of manufacturing process, but how can we use the definition to injection molding? I think I can further explain it later. And the third one is performance qualification, PQ. It means that by using objective evidence, we can make sure that a process under anticipated conditions can consistently produce the product that meets all the predetermined requirements. That is the stability of the molding. Molding stability has always been a very important issue because in reality, especially for medical devices molding, we often see the problem. That is, although our customers have told the manufacturers that this molding can be manufactured in a certain location, usually the medical device manufacturers have their clean room. So the products are manufactured in a controlled environment. Although they're using the same molding machine, the same materials, or the same condition, the quality of the products may still change. The main reason being that the materials are different from the metals or some other products because they may change. The quality may change and they may be compromised by outside reasons, for example, temperature or the air, so that we can see the change in a quality in these products. So I think we have talked about GHTF's guidelines for 3Q. We have talked about the definitions. So now we want to apply the concept of 3Q to injection molding. Why we need to introduce injection molding certification or validation for the medical devices? Because we want to have stable mass production. We want to ensure that the products are consistent in terms of the quality. And we can see the 24/7 injection molding criteria. 24/7 means that we work 24 hours a day, 7 days a week, meaning all around the clock. I want the quality of my products to be consistent all year round. Before the 3Q process validation, we need to make sure the objective of the 3Q process validation, that is, we need to have the measurable indicators for injection molding. There are 4 indicators. They are included but not limited. So for our manufacturers, they can negotiate with their customers and they can agree upon the indicators accepted by both parties. So these 4 indicators are just examples. So the first indicator is that we can have the quotation cycle.
Normally, the quotation cycle and the forming molding cycle, if there is a big gap between them, and it will cause a big difference between the cost. So normally, this is a very important indication for us to verify our mold. And the second one is run for at least 8 hours and less than 1% scrap and 100% efficiency. So the yield is consistent and at least 8 hours operation. So this is a very stringent indication. And thirdly, starting injecting acceptable parts within 3 modes. So this is the third indicator. And the fourth one is downtime. So any injection molding, of course, there is downtime. It can be, of course, there are expected downtime and unexpected downtime. And for expected downtime, for example, and to check the performance of the injection molding machine, so this is the expected downtime. And this is something we have to do. And these are very important indicators for 3Q verification. So the example as I gave you, you can realize that some of the objectives are very hard to achieve. However, if you analyze the situation and use the right approach, and maybe you can satisfy the criteria and you can still profit. And once we have these indicators in place, according to these indicators, IQ, OQ, and the PQ, they have to comply with this indicator so that we can transfer from different phases. So IQ, confirming the equipment specifications for molding stability. and the quality of these products are as good as expected. And during the molding process, the criteria, we will have to use the technology in different phases. So it means this is the approach that can achieve the best quality. So this is a systematic approach. And all the operators, based on this approach, so the same machine, the same molding machine, the same mold, they can achieve a consistent quality. And the secondly is the operation qualification. So maybe the way people interpret it is that instead of confirming mass production evaluation through small batch, no, it's actually we have to use in the IQ phase according to the criteria, initial criteria at the IQ phase, there could be corresponding changes, and we use that to observe the range of the inconsistency, meaning that in the mass production stage, we already evaluate at OQ stage and to define a range. And once we have the range in the PQ stage, we can monitor online instead of monitor the quality using manual work. No, it's very difficult to do that via manual work, especially in the field of medical devices. The third phase is PQ. So during performance validation, real materials are used to verify the molding operation limits established during OQ to identify when changes occur. It means that once we use the borderline defined in OQ, and then we can use that and to identify the yields and to make sure that we can produce high quality products. IQ, OQ, and the PQ, I just introduced to you the concepts of these qualifications. Of course, there are a lot of details, a lot of processes. And to put it in a simple way, and there are 3Q, IQ, OQ, and PQ. However, it covers more than three different phases. It covers part designs, material mold design, manufacture, and the injection molding machine specification, and also molding technology. I can give you some examples, some simple examples. In terms of product design, part design, in terms of satisfying the objective of the parts, and we also look at the geometry of the part and to see whether we can really make stable production. So in part design, what we can realize is that with the LT ratio, the longer it is, and we probably to the melt flow pressure loss. And one thing people normally neglect is the water absorption, water content in the, and that is going to affect the velocity of the material. So when we dry the material, we have different ways to dry the material, and that could affect the water content in our material. And that is why sometimes the production process and in the result is not that stable. And how do we reduce the pressure loss? And how can we make sure that when in the cooling process, we can make the material being cooled evenly? So these are the things we have to put into consideration in the production process. And also for injection molding machine specification, we know there are a lot of different indicators. And for medical devices in particular, injection volume, and how can you make sure that the injection volume is stable, and also the molding technology and the how do we use a systematic way and to make sure that the stable production. And now I would like to mention for medical injection molding industry, and I mentioned about the 3Q. So it really, it's about how for us machine makers, for example, data recording, and how do we interpret the data? So how do we collect the data? And we cannot collect the data manually. We have to use IT technology to collect the data, and we interpret the data so that we understand what quality changes happen during the production process. So this is the IMF 4.0, and we not only collect data, but also we have these 4 aspects we stress on. Number 1, stress machine, how the machines collect the information, the changes happen during the production process, and how do we do the setup and to complement the changes during from the external environment. And if there are changes from the external environment, and how do we adjust the setup in the machine so that we can communicate, make sure that these machines can communicate with each other. So this is the concept of smart machines. So once we have that, it's still possible that there are some issues happening in the management. Maybe the feeding, maybe the operator feed the wrong material, and the quality, of course, will be affected. So in this case, we have to use smart manufacturing together with the robot, and we can check the quality of the products. And all the changes, the data will be collected by IMF 4.0, and they will form a good cycle so that we can have a stable and the production results can be expected. I'll show you one video about our IMF 4.0. This is the what we exhibited in Taipei Plus 2018. So we collect the information real time, and we monitor the changes happen during the production process. And we can also, if there is any abnormal production process, we can monitor real time. We use sensors, and if there are any abnormalities, then we can use the robot to pick the defect. And we also won the award during Taipei Plus 2018. So this is also a lid production. So this is a two-component molding at the same time. So you can see the rotary table, it's horizontal, and we have multiple color materials. So we show you a short video regarding IMF 4.0. And in Industrial 4.0, there are several steps. Then first, IoT, we connect these machines through OPC UA or UMAC. These are the international acceptable protocols. And we collect the information during the production process. And through the data, we can have a good understanding of what happened in the production process, and we make it visual. And through this data, we can know what is happening on site. And through this data, we can expect what will happen in the production site. And if we know what's going to happen, we can use the algorithm. After we collect the information, we can expect what's going to happen to the machines and what adjustment we can make to the machine. So these are the process we introduce to our production process, of course. And if we go to the right, it's going to be more difficult in terms of technology. Now we are already developing the adaptable rules, and we also show the adaptable rules in the Taipei Plus 2018. So maybe we have some external variables affecting the production quality, and we collect the information, and we by our algorithm we will calculate what kind of adjustment we have to make so that we can have a better adjustment to kind of fight against the external variables. So we also give some examples here. The first example is simpler. This is about a IoT, about the data connection. In the past, at the client end, when the client wants to have production statistics, probably one personnel will be used to spend 8 hours to collect the information. And then if you have 20 machines, there will be a labor force need to be there, and if that can be automated, we don't really need the manual work anymore. And the trait of that is that, of course, we use our own machines, and we use the machines from other companies. We use the protocol to connect these machines together so that we can have the statistics, and we can reduce the labor we have to put. And that is in the we can reduce 330,000 NT dollars.
Now we can talk about the availability improvement. In the past, it was really difficult for us to specifically calculate availability unless you hire some people standing next to the machine to mark down the working and downtime of the machine. You could do it, but by using the interconnectivity function, we can calculate the downtime of the machine. And throughout the process, we can know that it is planned or unplanned downtime. So we can provide some countermeasures or improvement plans. Traditionally, we needed manpower to do that. But after using that, we have improved the precision of availability calculation by 2.7%. So we can provide better data to the management. On top of that, we can reduce the consumption of human power. Moving on, we can see the improvement of OEE. That is the overall equipment efficiency. So that includes availability, production, performance, and quality. So on site, in the past, we only got fragmented data, but through the IMF 4.0 system, we can quickly collect the data we need, and it can generate a chart immediately. If we do it manually, we need to consolidate the data and convert the data and change it, create a chart. It may take more than a day. So I think it was not so efficient. So actually, we wasted a lot of time in the past, and the overall efficiency based on the feedback from our manufacturers. By using the new system, we can improve the efficiency by 95.6%. So moving on, cost analysis and improvement. The IMF 4.0 system can record the downtime reason and the reasons for defective products. Later, the data can be sent to the management or the personnel so that we can create a countermeasures. What's the benefit? Because generally, on site, for example, for a special machine or product, throughout the process of manufacturing, some engineer may think that the mold or the products needs to be changed in a certain way. People may have different answers. Some may say, from their perspective, based on their roles, they may have different answers. So the reasons may differ, or the types of defective products may vary. But through the data collection system, we can categorize the types of defective products, or we can calculate the downtime reasons accurately. So in this way, we can better understand the total downtime and link that to the loss and the cost. So the more products we have, the more categories we have, the higher loss we may have. So what's the countermeasure? How much more resources do we need to invest in to solve the problem so we can have a comprehensive solution to quickly address these issues? In addition to these reasons, we actually help our partners to interpret the data. By collecting data and interpreting the data, we can determine the defective products quickly. For example, by collecting the parameters of the data from different cycles, if we change a certain parameter, for example, we have an example. We see that the time changed by 15%. So we ask our customer to take several actions, for example, to check the machine, to check the molding, to check the injection. Finally, we found the problem was from the machine. Then we make the improvements, and after that, the time for adding materials was back to normal. So actually, all these were confidential data, so that's why we didn't publicize the information here. But if you're interested, if you want to know more, if you want to interpret the data, if you want to find out what's happening throughout the process and what's the cause, if you want to interpret the data and to improve the process, you're more than welcome to contact me. We can introduce the system to you so that you can find out the overall situation of your production so you can make improvements. So this is the QR code of my company. For those of you who are interested, feel free to contact me or contact my company. So this is also my personal QR code. You can also reach myself. If you have any questions regarding the IMM or mass production, you're more than welcome to reach out to me so we can have exchange of opinions and we can learn from each other. And I'm hoping that our injection molding technology can be helpful to you. Thank you very much. Thank you to Dr. Lee for your wonderful sharing. Now we're moving on to our final presentation. We are going to welcome Head of ACM Taiwan of Henkel Taiwan, Mr. Eric Wu, and he will talk about innovative application of non-solvent resin in the assembly process of medical materials. Please welcome Mr. Wu. Thank you very much. Thank you to the organizer and thank you to the participants online. So I will talk about the medical device production powered by non-solvent adhesive innovation. Now I would like to first introduce myself. My name is Eric Wu. So from 1994, I started working at Loctite Taiwan. So I have been working at the same group for over 25 years. So as you can see, from Monday to Friday, I'm a salesperson, but on the weekend, I work with the wood. I also enjoy marathon. I also wear the shoes made from our own adhesive. I enjoy cycling, and the bicycle I ride is also made from the adhesive manufactured by my company. So adhesive plays a very important part of my life. Today, I will talk about the adhesive application in medical device, but I think over 80% of the medical devices can be assembled by adhesives. Only about less than 15% of the medical adhesives are used. So our previous speakers have also mentioned the 3Q validation process, for example, the stability of the materials and so on. When we are using the solvent adhesives, sometimes we need to think about some criteria. For example, they have to be stable. We need to control the temperature. They have to connect the same material so that we can use solvent type of adhesive to connect them together. When talk about medical devices, if we want to innovate them, adhesives can become a very important player. How can we bond different materials? Or if we want to combine different creative materials, or when we're using PET alternatives, we need to also come up with some alternative adhesive technology to assemble different products or materials. In Henkel, we are a chemical company. On the right, you can see we manufacture Persil detergent. We also provide beauty care products, for example, hair products, beauty products. For these two business units, they account for 50% of our overall sales. On the left, adhesive technologies. That is the main core business unit of Henkel. If we put the three elements together, I think this comes from our deep involvement in adhesives. From home care, for example, hair products, we have received a lot of information. We know what kind of raw materials or formula will not be harmful to human body. They are suitable for human use. And by using this kind of knowledge, we apply that to medical adhesives. So we can work with the medical industry hand in hand. Today, these are the outlines of my talk. I'll talk about the assembly of the medical device, how to use the medical adhesives. I will talk about the adhesives in medical electronics. And in a later part, I'll talk about pressure-sensitive adhesives and 3D printing applications. And how can that support the traditional adhesives? How can we fill the gap that we see in the industry? So from here, you can see the box on the left. These are the single-use medical products. On the right, these are the medical electronic products. What are the differences? The products inside a red box are consumable products. We need to reduce the unit price. They are disposable products. On the right, it's all about quality and performance, but the unit price is much higher. In terms of the medical adhesive, the products inside the red boxes actually use large amounts of medical adhesives. But the medical adhesive supplier, in order to reach the scale of economy, I think there is still a long way to go. Moving on. So, in the medical adhesive industry, I think the adhesive industry actually follows the medical industry. We have faced a wide range of issues like aging population, home care, or patient care because people are getting older. So the medical resources are facing great pressure. So home care and remote monitoring or remote diagnosis will become more important. Therefore, we need the support from different devices to support the patients. In the past, they need to go to the hospital, but now they can be treated from home. Also, we need to control the costs. In advanced countries, they have more medical resources, so people enjoy good medical services. But in the not so developed countries, how can we share the medical resources to all of the human beings? So we need to have low cost production. In the meantime, we also need to maintain the quality. Let's have a look. So my presentation covers not only the products from Henkel. For all of the adhesive suppliers, when dealing with the medical industry, they do have an important mission. There are 4 circles. If a medical adhesive supplier cannot meet the 4 criteria, I don't think they'll be able to work in line with the R&D. So the first is the no change policy. When talking about medical devices, adhesives will be used. We cannot change the formula easily. But for adhesive manufacturers, if we want to use that in medical devices, it's really difficult to achieve economic scale. So it is really difficult for us to reach the no change policy. Secondly, we need to meet the ISO 10993. All of the medical supplies have to be certified by the ISO 10993. Like in Japan, Korea, and China, they have different certification. So the ISO standard, maybe like, for example, that the global standards or the US standards, for example, USP6, these are the important certifications. With these certification, we can ensure that the quality of the materials will not be compromised, they will not be harmful to human bodies, and they will not stimulate the skin. So we can make sure that the end products, when going through the 3Q validation, will not fail. If you cannot get the materials you need, if you change the formula, that may be the source of the problem.
On top of that, the product portfolio needs to be comprehensive. So I would just go through them very quickly. In the world of medical devices, basically you won't see the adhesive because it's hidden inside. So how do we know that what materials are being used as adhesive? I'll show you that. And also reliability. When we talk about adhesive, of course, the bonding strength is very important. But for medical devices, we have to also consider other factors such as sterilization and how the sterilization process is going to affect the bonding strength for the adhesive, for example. And I'll just give you some examples of that. So normally when we use the ISO 10993. So for this standard is used for medical devices. However, we also agree that in the world of adhesive, we believe that we also have to simulate whether we can apply to this ISO standard to prevent possible problems. Because for adhesive used for medical devices, and it's very active chemicals. If we choose inappropriate materials or the 3Q validation is not realized, then the adhesive that is not cured or the materials undesired materials appeared in the final products, it will definitely be problematic and even jeopardize the ISO standard our customers have. So how we test it and how the sample is taken taken, and everything should be recorded very carefully. So for adhesive, it not only bonding things together, but it will also have a possible impact to the ISO standard in the finished products. And this is one example. In the past, we saw a lot of toxicant, and now we also have the NAMSA. Basically, we use the third-party laboratory to do the validation to ensure that the materials we provided to our customers for the medical device production will not cause any problems. For example, the test include a muscle implantation and the animal test to make sure that the materials are safe. It's not only from our company, but also the other well-known adhesive suppliers. These are the tests they will conduct. The only difference is that how many tests they conduct. So we always say that 10993. This is the general standard. But for different adhesive suppliers, they might be selective. They don't do all the tests, but they just pick some of the tests they do. So let's have another look. And for adhesive for medical devices, for the past 10 years, the biggest change is the phase out of PVC material. In the medical devices material, we don't really receive the instruction that we have to stop using PVC, but this is the world trend, especially when we or catheters, or we want the materials to be soft. And so if the catheters are soft, it's not going to be it make the patients feel more comfortable. But however, if we want to make the material soft, we'll have to put a lot of plasticizers, and it will affect the environment. And it's possible that the plasticizer may migrate to the patient's body. So for the medical device suppliers, they're trying very hard to find a replacement for PVC. So TPU is a materials that is more matured to replace PVC. So to use PVC, of course, TPU, of course, it solves the problem of plasticizer. However, it brings more challenge to the adhesive. Moving on. For adhesive providing to medical device manufacturers, and I'll show you how many the types of adhesives provided to medical manufacturers, and we see that Licura, acrylics, and all kinds of different materials. And of course, we need a mass production and fast cure materials. We probably will phase out the. We don't really use the problem of epoxy is that it takes a long time to cure. So we have to, if we want to put a mass production, of course we want to have margin, and we have to put things into mass production. So for all the materials we have, and we have to be able to, if we consider the mass production capability, we probably will consider light cure acrylics more. And for this material, it gained a lot of advances in recent years, and is mainly driven by LED technology. So light curing, if it's using UV, temperature was an issue, and if it generates high temperature, and it's going to damage the medical devices. However, if we use LED, it's not going to have the issue of high temperature. And compared to UV, and the LED is more durable. For example, the service life of light bulbs is 20 times longer than the UV light. And for these materials, it's widely used for the light coilings. And I also bring one sample here. It's a 3-watt power, and we use a USB, and we have this. It's easy to use. And before we had this LED devices, the light curing devices probably will consume the power of 200 watts. Now this one is only 3 watts. So with this kind of devices, LED devices, it will allow us to have low cost and to achieve the same results. And of course, we use our own equipment, and I believe that different companies, they have different cost structure, but the differences should be small. And the main difference is the light bulbs replacement. And for 5-year service time, if you use the LED light source, you don't have to replace the light source very often. But if you use traditional mercury light, then you have to replace the light source very often. And you also, because of the high temperature generated in the processing, then the summer stability will be sacrificed during the processing period. So here we see some of the lighting, and on the left-hand side, we see the LED technology and the high-pressure bulbs in the middle. And of course, we can use them all in the light cure process. We believe the LED is the trend for the future. So in recent years, we see that for light cure technology from different adhesive suppliers, and they all go for the LED technology. And at least this is the trend. So how do we do QC? How do we ensure the quality? And so this is the accessories. We use these accessories to check whether these LED technology or the light curing technology can be stable and have good results. And for light cure systems, it can apply for different applications. And so basically, 20 years ago, and light cure systems basically were widely used to replace epoxy, because a light cure system, it only takes 3 to 5 seconds to complete the process. And for light cure resin, we also evaluate and notice one thing, that for medical devices, if it's opaque and it's not transparent for different syringes or different catheters. If we want to have different color code and to make them more identifiable, and it's difficult for light cure adhesive because the light cannot go through. And in that case, we have to consider other technologies. And for light cure, we have the flexible and the rigid. And for rigid, this is the technology 20 years ago, and the flexible is the recent modern technology. And for invasive treatment, of course, and the patients do not want to have something really hard to be inserted into your body. The insert parts, if it's softer, and the patients can endure the pain. So when we see the development of different materials, we see that the flexible technologies, we see the elongation is more than 200%. And because we know resin is something really hard, and to have the elongation for more than 200% is actually difficult to achieve in the production process, because we know that the acrylics, and they are transparent, and to monitor the production process, you see the fluorescent adhesive. And the adhesive actually is transparent, and we use fluorescent to monitor the quality of the products. And we can see that by design, on the blue one columns represents the old technologies, and the red one means the modern technology. And for the red one means that the elongation percent can be more than 200, and also it can increase the strength and greatly improve the adhesive for flexible materials. I'll show you one video. And why do we need these flexible adhesive? This is PC. On top is the hard PC, and together with the soft material at the bottom. So this is another material. I will place them together so that you can compare the two. PVC plus plasticizer at the bottom. So you can see the one on the left, it can bear higher strength. So the difference is, you can see it took us 10 years to make the improvement for only 2 centimeters. And LED cure materials, if we want it to be flexible, mainly because of the development of these catheters. If we use a hard adhesive, the materials will not be as durable. And so here we show you the rigid LED cure adhesive. So in the early days, because these materials are hard, the syringes are hard, and acrylics are hard, so it is okay to use hard adhesive. But now we use flexible adhesives and for the use of soft flexible catheters. Like I mentioned to you before, the use of materials, some of the materials are not transparent. The light cannot go through. And for opaque materials, can they be cured properly? And so we think of the other materials. Let's look at so of course for cano acrylics, of course it can have the bonding strength, and it's difficult to cure it very fast.
Also, if we can add the curing function, then they can be used in the line. You can see the upper right corner. So the thread for surgeries are different from the thread we use for sewing. In the meantime, for the through the function of the primers, we can have better adhesion. Moving on. When we talk about the flexible instant glues, they are the new products manufactured just about 5 years ago. Generally, the instant glues cannot be used for flexible adhesives because the instant glues, their elongation is only about 2 to 3%, but the current technology can go over 30% of elongation. So the instant glues can be used for flexible products. 2 years ago, when we worked with PIDC, we conducted some analysis. We used it for P-bags. So on the left, you can see they consume low energy. This surface low energy is lower than 30 DIYNE, so it's about the same as PP. But P-bags is very flexible. The elongation break is 750%. So it took us a lot of time to find the right material P-bags. So we used the soft instant glue to address the problem. So you can see the adhesion. So we have tried like P-bags 1.9 or 1.7. It shows the parameters on the outside. So you can see the deep blue bar 4902 FL. It's a flexible instant glue. The elongation is over 30%. On the right, the left is the adhesion of the hub after elongation. The P-bags elongation is 750%, so it's really good. So only this kind of soft instant glue can help us solve the problem. I'm not telling that you have to use the soft instant glue because the cost of flexible instant glue is very high. But there's no other way we can do because generally the acrylics cannot help solve the problem. In the meantime, we also see different heat agent to find out the change in the strength. So after the gamma sterilization, we don't see any change in the acrylic. So we are very excited to see that the reliability of the new formula is really good compared to the traditional type. In the past, when we provided the instant glue, I think that our new products actually perform better. Moving on, when we talk about the medical devices which can be used repeatedly, they are not the single-use products. For example, like endoscopes or orthopedics instruments, they have to be used repeatedly. So they need to be able to handle some aggressive sterilization centers. So like thermal or steaming process are usually the ways. So usually we use epoxy as the adhesive, but epoxy resin has to meet the ISO standard. In the meantime, I also want to show you how the adhesive is used for dialyzer and oxygenators. So for the membrane filter, for example, in the red part, you can see the adhesive, the potting, and also the bonding. When using for dialyzer, I think the technology is already very mature. Over 99% use the PU, that use the material that meets ISO 10993 to create these products. So among these medical devices, some of the previous speakers talked about the products made from plastic injection. What I'm going to introduce now is not the same. We use the low pressure molding application. Usually the injection force is about less than 6 kilograms. And they're making the sensitive electronics products. Traditional injection may have the force over 50 kilograms, but when the parts that cannot handle so much pressure, then we use the low pressure molding application. For the low pressure molding hot melts, usually they're polymerites, so they also meet the ISO standard 10993. And for low pressure molding, in addition to the parts, we also have some hearing aids or other probing devices or sensors. They can be used in these areas. Moving on, you can see the electronics adhesives. In terms of the packaging for electronics adhesives, now we have the total solution. Personally, I think that in the future, we can still work harder in terms of the smart catch. Smart catch means that all of the things that can collect the sensor, we can use the adhesive that meets biocompatibility. We can directly attach them to human body and we can extract the data directly so we can let you know how you are doing. So traditionally, you can see the electronics assembly. So on the board here, we have so many different components, but For the electronics components, we don't see a lot of change, whether it's medical or not non-medical. But like this one, smart patch, we do see great improvement because when it comes to smart patch, all of the printed electronic materials have to be placed on the flexible substrate. And we also need to use the PSA glue to attach that on human body. So the technology involves what you can see, for example, the stretchable silver ink or PCB ink. We need to change the electronics based on temperature and also electronic circuit. So we can further strengthen the function of substrate. I think now our technology is mature enough so that we are able to create a smart patches for people to use. Also, we have a dedicated team. A few years ago, when I talked to people in the industry, I think here in Taiwan, we haven't developed these kind of advanced products. So we have the two types of patches. We need to show that it is non-cytotoxic. The patch will not be irritating to the skin. We need to make sure that these are the basic criteria. So we have the new bondage or the products medical plaster for medical care. Now moving on to the patches, where you can see we can have the wet one, we can have the oral one, we can have the transdermal one. In terms of the oral one, we need to think about the dosage. There will be a peak, so it's not distributed evenly. But if we use the transdermal patch, the medicine inside a patch and a compound, when released into body, we can see the stable release into human body. So this is the transdermal patch. And the most important thing about the transdermal patch is that the medicine and the PSA should be compatible. So compatibility is key. There are also some other criteria, so I won't go into the details. So in terms of the medical compatibility, we have a team in the United States. So we show the ingredients in the database. We will run the calculations to see that in a starting point. So we use trial and error. So we want to quickly get the answers. Moving on. In terms of the development of adhesives, we also use 3D printing technology. The development of 3D printing, as we all know, now we're wearing facial masks. We know that the technology of 3D printing is that as you can see from the slide, whether the unit price of the materials is high or low, no matter whether it's complicated or not, the price is fixed. So you can see the price of products manufactured from 3D printing is the same. So the price, unit price is fixed. So people usually think that I can use 3D printing to create a prototype. It's not suitable for mass production. But now I would like to share with you an interesting case. Another feature of 3D printing is that we can create a product to enter the market quickly if we can break through the bottlenecks quickly. Now, in the pandemic, we can have the PCR test. So you can see the nasal pharyngeal swab. So you can see the swabs are actually made of plastics. They have complicated shapes. Starting from last year, as the outbreak of COVID-19 starts, so actually these swab manufacturers have very low production. Right in the beginning of the outbreak, the supply could not even meet the demand, but people have urgent need for this kind of swabs. So as an adhesive supplier, we work with a platform called Origin. So it's a supplier. So the resin supplier and the device supplier work together So for example, last year we have the national team for facial masks. In a short time, they created the swabs because that's the sterile products. So it's all sterile. So throughout the process of manufacturing, you need to make sure that there's no DNA in the process, and we need to create the products in a clean room, and it has to be packaged and sent to the market, meeting all these criteria. So all these meet the criteria of 3D printing. So now they are able to reach mass production. They can manufacture thousands of products per month. So from here, you can see this is the traditional 3D printing product. So I won't go into the details because, well, we can use 3D printing to create a mold. So before mass production, we want to create a prototypes or the molds. I just want to tell you that the resins used for 3D printing also have to meet ISO 10993. We also encountered some problems. Some of our products during the process of molding, they use the resin for 3D printing. They use the adhesives. There's no problem with assembly, but we ignore one important fact. That is, in mass production, we are not using the same resin for 3D printing. The material is different. So in the final stage of production, we need to start everything from scratch again because in terms of validation, we use the resin for 3D printing, and it's not the end product or it's not a real material that we use in the final stage. So this is my final slide. For our participants online, I strongly encourage you to have a look. So from the left, we have a club for information exchange. So we welcome our friends in the industry or even our peers. You're welcome to join this discussion group because we talk about the problems we encounter in the adhesives, and some experts outside the company would answer a question. I cannot promise that all of the answers are correct, but we create this platform for communication. So we encourage you to join us to engage with each other to solve the problems we encounter in this community. We have over 2,500 people in this community. I think when our peers, when you try to look for answer, I think this is a very effective way. So this is my final slide. Thank you very much. Thank you, Mr. Wu, for your sharing. Moving on, now we're going to start with the panel discussion. We also use the Slido system to encourage questions. So you're welcome to scan the QR code and you can raise your question or you can like other people's questions. So we would like to welcome back our moderator, Mr. Yao Gui Xiao, General Manager of Plastic Industry Development Center, PIDC, to serve as moderator. Our panelists include Mr. Johnny Chen, Chief Technology Officer of Genshin Group, Channing Lee, Deputy Director of Eternal Materials, Vincent Lee, Director of Field Application Engineer of FCS, and Eric Wu, Head of ICM Company Henkel Taiwan.
Dear panelists, our online participants, ladies and gentlemen, good afternoon. First of all, I would like to welcome you to join the Plastic and the Rubber Industry Trends Forum, organized by Bureau of Foreign Trade and implemented by TITRA and PIDC. So in the morning, we heard and a lot of presentations, and in the afternoon, we're going to focus on the innovation in transportation applications, and the second topic is the innovation in medical applications, because we know that plastics it's very closely related to different industries, and any innovations, any new directions, definitely the rubber and the plastics industry will be affected or will be engaged, because this is the material widely used in different industry. So at the beginning, allow me to introduce our panelists. So our first is Mr. Johnny Chen, Chief Technology Officer from Genshin Group. Welcome. And Mr. Chen has abundant experience He has 45 years of experience. So it's almost half a century of experience in injection molding machine. So we will learn a lot from him. And the second panelist is Dr. Vincent Lin, Director of Field Application Engineering Center from FCF Group. And he is also the lecturer from our center, Plastic Industry Development Center, and he is very popular lecturer in our center. And the third panelist is Mr. Li Chuneng, Deputy Director of Internal Materials. And Mr. Li is the has held different positions in internal group. So we're going to hear from him about the development and the latest trends of how thermoplastic composites and how it's related to weight reduction. And the fourth panelist is Mr. Eric Wu, and I just had a chat with him. He worked very hard, and he even played harder. You can see from the picture, and he's a marathon runner. He also rides bicycle, and he also, well, when he is off work, off duty, he is also having a lot of different activities. And it's also a carpenter, amateur carpenter. So welcome him. We start from the innovation of transportation application. So we heard from Mr. Chen from Chenxiong Group, and he mentioned multiple times of one technology trend in the electric cars. Of course, number one is battery. Of course, the battery needs to be recharged faster and with longer life. And another important technology about battery is that how we can make our vehicles lighter. This is a very important technology. So if we can make the battery lighter and make the car lighter, and of course we can make the car lighter, we can make the battery with longer life. So it means that we have still, because 80% of the materials used for the in the car, and of course, we know that plastics are lighter than metals, and 80% of the materials used in electric cars is steel and the glass. And it's not only the cars, but also we see other applications, satellites or scooters, or even in aerospace, and how to reduce the weight. It's an important issue in these industries. And of course, plastic is going to play a very important role in the process of weight reduction. And the topic we focus today is transportation innovation. Of course, it has wide range of applications. In Taiwan, no matter where you go, you see the blade for, we see a lot of wind turbine, and we see the blades in wind turbine, and in the future, and we know that the blade can be as long as 100 meters. And how can we produce the blades? And of course, it needs to be lightweighted. Now we use the glass fiber composites, and in the future, it's going to be a carbon fiber composite. So first of all, we'll invite Mr. Chen from Chenxiong Group. A few questions for you. Mr. Chen, you mentioned about the contribution from injection molding industry and its relation to the electric car development. And from the perspective of electric car, and if we, what are the special challenges in terms of the injection molding machines application in the electric vehicle production? And do you have any experience you can share with us, especially for injection molding facilities? Is there anything else we can do to widen the applications? And we please invite Mr. Chen to answer the question first. Thank you. Thank you for your question. I would like to share with you my company, Chenxiong Group, share with you our experience. First of all, we make this machine larger. Once we make the machine larger, we can centralize the parts, and because in the process of centralize the parts, in our company, we continue to study how to make the machine larger. Our largest product is 6,500 tons. So this is the first direction. We are making our machines larger. And the second direction we're going is that, for example, we're trying to make the parts lighter, and for physical foaming facilities, we also install some of the facilities for our customers. And the third direction is the composite materials. And I've been observing the development of composite materials for a long time. It is not something that can be completed by the injection molding machine. So we have to work together with carbon fiber suppliers, and also together with adhesive suppliers, because for these materials, and their chemical traits, their chemical characteristics are all different. And all the technologies for these fields are advancing. And we want to make better parts, and we need to work together across different industry. We believe that this is where we can work harder together further. Thank you. Mr. Chen, you talked about the foaming technology. Actually, this is a very important development in weight reduction, especially from the perspective of materials, and together with the processing steps. And if we have the time, we will continue. We will ask more details to Mr. Chen. And the second question is regarding materials, because for Mr. Chen, you mentioned that to correspond to the material changes in the development of electric car, just like the foaming materials, there are a lot of material advancement. And we also heard from Mr. Lee from Eternal, and I would like to ask Mr. Lee from Eternal, and for thermal plastic composites, it's been developing in Taiwan for a few years. And so the first question is that in the past, when the external why do you use thermal plastic materials instead of thermal setting composites? And the second question is that when you started to work on thermoplastic materials, is that because you see the future trend? And if that is the case, do you have any concrete example you can share with us? These are the questions for Mr. Lee. I would like to share with you that for my company, Eternal, it was it was established 57 years ago. And 57 years ago, the popular technology was a thermal setting composites, and including glass fiber. And for eternal, and in Taiwan and in China and in Southeast Asia, we have factories to produce this material, unstructured resin. For thermal setting composites, it has some advantages. It has its pros and cons. And the reason why it was very popular before is because the material was inexpensive. However, it has the short back because it was liquid. So it has POC, and the cycling time is high. That is why the cost can be high. So for some products that need massive production, it may not be suitable. So more and more products are using thermoplastic materials. And the advantage of that is it doesn't have POC, and the manufacturing cost is lower than thermal setting composites, but the short back is that the strength is not as strong. So the haze issue is something that we have to overcome. And for thermoplastic materials, of course, we see the opportunities in sports market. For example, our bicycle industry is very well known. In the past, we have the thermal setting composites material. We see the bicycle use these materials to make bicycles, and the cost is pretty high. So a lot of the people are still using alloy, aluminum alloy made bicycles. So if we can use the thermoplastic materials, the carbon fiber, if this material is used, and then we believe that it will make the cost of manufacturing bicycles a lot lower, and people can more afford bicycles even more. And there are some, for example, the golf carts, other applications, or a treadmill. So these are the applications in the sports market.
You also talk about the use in sports or transportation. We need to make the transportation vehicles lighter, and we can create a more friendly environment. Why? Because if the materials are lighter, then the EV batteries can run longer because the cars are lighter. And for the fuel-powered vehicles, if they are lighter, their fuel consumption can be lower. So we can reduce the carbon emission. So in the future, if we can use more thermoplastic materials, which have lower production cycles, then I think more and more manufacturers will use thermoplastic materials in the future. So I think it is a very promising materials in the future. And for high temperature transmission products, in the past, we used metals to make sure that it's highly durable. But again, metals were too heavy. So making them lighter was always a big problem. Metals also conducts heat. If we don't want to conduct heat, then we can use other materials instead of metal. So by using thermoplastic materials, they are heat insulated, and they are durable, and they're lighter. So I think That's my opinions on thermosetting and thermoplastic products or materials. Thank you, Deputy Director Lee, for your explanation. Mr. Lee just mentioned that in the early days, eternal materials also use thermosetting composites, but now it's using more thermoplastic materials. And Mr. Lee said that they have their own pros and cons. For the products that needs to be more durable, mostly they're still using thermosetting composites, but the rising trend is that for transportation products, thermoplastic materials are more popular because thermoplastic products are more environmental friendly because they can be recycled. Production cycles are shorter because they don't need to respond. So the process will be shorter. And they can be used in more diverse ways because the types of thermoplastic materials do vary. So they are efficient, they're time saving, and they're diverse. So all these are the new opportunities. And now people are talking about environmental protection. So I would like to share with you one interesting case that is also related to the COVID-19 pandemic. Because of the pandemic, a lot of industries see the disruption of their supply chain. In the past, the supply chain could supply real time, but because of the pandemic, manufacturers cannot work, so they cannot provide the materials or the finished products. I work with a military company. They provide component parts for aviation. They use the thermosetting composites, but if you have used that, you will know that we have to create a preplate. The preplate have to be kept in low temperature because the thermosetting composite will react. So they can only be kept for 6 months. So for the National Defense Institute, they need to keep certain storage. But when they receive the order, they don't have the material, but the foreign supplier cannot provide a thermosetting material, so the value chain is broken down. So they came to PIDC asking us what they can do, how to prevent this kind of problem from happening again. So after our discussion, we thought that the best answer is that we can use high-performance thermoplastic materials. So both parties created a prototype for them to use after validation. They found, the product is really useful. So if we can expand the use of thermoplastic materials to other industries, it shows that we don't need to worry about the disruption of the supply chain because our composite, meaning the thermoplastic materials, can last longer. We don't need to think about the storage time of the material. So I think this is another benefit of the thermoplastic materials compared to thermosetting composites. So we raised several questions regarding transportation to Mr. Chen and Mr. Lee. Moving on. Let's talk about the innovation of medical supplies. So Mr. Lin from FCS talked about the features of medical devices as well as their digital trend. And because of the COVID-19 pandemic, the medical supply industry has received a lot of attention here in Taiwan. Due to the impact of COVID-19, many industries are severely impacted. The medical device industries, on the other hand, are facing positive impact because they have a lot of requirements for zero contact. So originally, we wanted to have a physical event face-to-face, but now it has become an online or virtual forum. So now when we're talking about zero contact, so we have a lot of online event. Yesterday, I went to the general hospital in Taichung, Veterans General Hospital in Taichung. So we talk about remote diagnosis or remote medicine. Our remote team can take care of these medical issues remotely. So now when we talk about the zero contact manufacturing, so we want to talk about smart manufacturing. Without any human, we can still run the plant. So we talk about importance of smart manufacturing. And so I think that is really related to the medical supplies industry. So my question for Mr. Lin is that what are the products manufactured through injection molding? Because probably there are different ways to manufacture the medical supplies. Then, if we're going to use injection molding process to produce the medical devices, what are the requirements? So these are my questions for Mr. Lin. Thank you for the questions from our moderator. I'm Vincent Lin, director from FCS Group. We are a manufacturer of the IMM, injection molding machines. So I think the IMM can create products made from thermoplastic products. Our machines are sold to manufacturers of facial masks or other devices or syringes. So we sell our machines to the medical suppliers. What are the criteria? First, precision, stability, and also cleanness. Usually they would order the all electric machines so that we can meet the requirements for injection molding. On top of that, we also care about the injection unit. In terms of the process of molding for medical devices, why we need so many validations or certification? Because some of the parts or products are related to people's life. How can we ensure the consistency of the quality? How can we make sure that when using the products on human body, there is no problem for safety? Experts all know that in the field of injection molding, there are a lot of external factors that may affect the quality or the stability of the products. So it's not just about the equipment for the IMM. We also think about the molds, the dry management of the materials. We need to make sure that they're dry, and the design of the products. So to ensure the overall quality, we need to see the big picture. Sometimes people get confused. Well, this sounds so complicated. How do we know the relations? So in terms of the design of the products or the machine or the choice of the specifications or the management of the materials, there's one key. What is the key? That is, how do we ensure the consistency of the plastics and the mold? The first one is that the change in consistency or viscosity. How can we make sure that the viscosity is consistent from the design of the machine or the design of the machine or the choice of the machine? We need to think about the viscosity of the plastics. Secondly, when the liquid is flowing in a mold, we need to control the density. That is, we need to control the pressure. Well, we can set the pressure from the machine or set a time. But in reality, in terms of the design of the machine or the product, what are the factors that may affect the flow of the liquid, that may change the density of the liquid? It's a big problem because the change in the viscosity, or how can we ensure the pressure or ensure the density that may cause the change in the pressure of the product. All these combined, I think for a medical supplier, they need to think about all these factors, because for the IMM supplier, they only provide a machine. But for the medical product supplier, what they want is that they want to ensure the quality and the consistency of the products. So that's the key. So for now, in terms of the design of the products, the mold, the adjustment of the parameters, and the choice of the machine, all these combined, from my experience, I don't think we have an integrated solution, because what we can do is to provide our experience from a IMM manufacturer, and it's really difficult to ensure the lasting consistency for the product. So if you're interested, I think this is something we have to think about. And in the future, I think this is a very important problem we have to address. So how can we validate? What's the second issue? How can we interpret the data? In the past, we use our experience to interpret the data, but through data collection or data interpretation, we can find out the problem. So it will help us address the abnormality, and we can do it more accurately. So when you're explaining the problem to your customer, I think that's strong evidence. So in the process of injection molding, we do not have the talent to interpret the data. So maybe some schools are training the personnel, but I don't think the schools have enough experience. We have a lot of people on site. They do have a lot of experience, but they don't really know how to interpret the data. So that's another area for improvement. Thank you. Thank you, Mr. Lin. So Director Lin talked about, in terms of the injection molding for medical suppliers, quality matters. That is the overall or long-lasting consistency of the quality. That is really important. So Director Lin said that. He mentioned several important points, because throughout the process, how can you ensure that the parameters of the production can be analyzed, can be interpreted, or can be stored? Because if something goes wrong with the medical device, we need to have traceability. We need to go back to all the steps. We need to go back to the data to find out where the problem is. So in the production line, I think that's a very important point medical suppliers have to think about. So if you're interested, I think this is something you can think about. And Director Lin also talked about the quality consistency and safety of the products. These are important areas. Moving on. So my question is for Mr. Wu from Henkel Taiwan. He has talked about the medical adhesive safety. For example, the contact of human skin or body weather that would cause allergy for people. So I think that's another important feature of medical adhesives. So my question for Mr. Wu is that, first, based on Henkel Taiwan's experience, how is the medical grade adhesive different from the general industrial adhesives? Because Mr. Wu talked about a lot of adhesives used for the industries, not for medical purposes. So I want to know, how are the medical grade adhesives different from the industry grade adhesives? And Mr. Wu has talked about the ISO 10993 certification. So my second question is that, could you please elaborate more? Why the medical adhesives need to pass the ISO 10993 certification? What's the difference?
谢谢主持人。
Thank you. We are adhesive supplier. Whether it's plastics and with the composites, and the major difference is the unit. For we only use gram as or kilograms as our unit measurement unit. Every year, one single product, probably we have maximum supply for 5 tons, and it's difficult to get a raw material. So to satisfy the demand for medical devices, and of course, we have to claim that we do not change our materials easily. Probably we just change the material once in every 20 years. So it is not easy for us to get us the raw material. And the benefit for our customer is that it's consistency. For example, maybe there is one medical devices being produced, and maybe there is some toxicity for the human body. No, we will not have to worry about the losses like that. because if we comply with the medical certification, we can avoid posing problems to our customers. And for a medical device design and in the overall process, actually the adhesive is the last step to complete the medical products. And the medical suppliers, they think that we should have adhesives, but that is not only the case. For example, the silicone material, it is actually silicone. It's very difficult to bond, and it's not easy to find solutions to have adhesion for silicone material. And I also heard from Dr. Lin from FSC about the stability of the material, and this is also the issue we faced before. There are some of our customers, they have stable materials, and maybe some batches of the materials, and the form is not stable, and so our customers, sometimes because of the precision, there are some problems with the precision, so they will need adhesive to help them so that they can ship their products to the market. And so if there is some precision problems and they ask the adhesive supplier to help them solve the problem, and we have the adhesive comply with the medical ISO standard, then we can help our customers. So for medical devices, this is a very conservative industry, and if we can comply with the ISO standard, of course, we can make sure that the last step does not have any issues. Thank you very much, Mr. Wu, for sharing your experience. And you mentioned a few the traits for the medical device industry, and the quantity might be small, and so it may not be cost effective because of course the profit is attractive. However, the volume is small, so some people, when they're considering going to in this market, and the cost effectiveness is something that people consider, and that is why the reason why the development of the medical devices industry is not developing as fast as we expected. And now, because we see in Taiwan, we're almost always and well known for our advantage and competitiveness in mass production, and that quality is not the traits of the medical device industry. And we talk about added value in medical devices. Number one, we see that the medical devices has high margin, gross margin. I saw the data in 2020 for listed companies. So the gross margin is 40.7. So it's almost higher than the semiconductor companies. So for medical devices, they are, most of the products are a type 1, and type 2 and type 3 are the products enjoy the highest gross margin. And Mr. Wu also mentioned one concept, and the formula hasn't changed for 20 years, and that the probably only changed once in 20 years. And the reason why the formula is changed is because short of raw material. So for our center, we work together with many companies, and many of them haven't really got changed their formula, and it's not because they don't want to change, it's because their users stop them from changing the formula, and it's because of the safety issues and because of conservativeness. So this is something very special about this industry. So this is our round 1 Q&A, and for round 2, I will ask all the panelists, each of you please use 2 minutes to provide your comments and to share with our online participants for these your thoughts, your experience, your comments regarding the 2 themes in the afternoon. So we start from Mr. Chen from Chen Xiong Group, please. Thank you. Injection molding machines And this industry is a industry that consumes quite a lot of energy. The level of energy consumption is about mid to high level. So now all the suppliers already had some breakthrough in terms of energy efficiency. Now the injection molding machines that they have achieved energy saving for more than 50%. So we have gained quite a lot of progress in terms of energy saving. Although we are not highly we do not create a lot of pollutants. However, now, all the governments around the world, they are having more and more strict rules in terms of water pollution. In the past, people may not pay attention to water pollution, but now for water taste and water treatment has become a very important issue. And another thing is air pollution, because for injection molding industries, because of materials, and some materials will release harmful particles in the air that is harmful to the human body. And in the past, these pollutants were just released to the air. But now, according to the regulations, the new injection molding machines or new injection molding factories, they have to monitor the air quality and to recycle the polluted air. So this is something the injection molding machine suppliers will have to tackle. And so we have to reach certain level of automated air quality monitoring. So this is the direction we're going. Thank you. When Mr. Chen also mentioned one thing that is very important, we mentioned in the morning about the circular economy. In the past, when we're running a company, and as long as the overall economic environment is good, and then we can grow our business, that is good enough. But now, where we're running a company, we have to put a lot of things into consideration. Just like Mr. Chen said that. In the past, the only thing we have to care about is that we make good products, and now we have to put the sustainability issues into consideration. We have to monitor our waterways, water treatment, and air pollution issues. We all have to be responsible and to comply with sustainability qualities. And there are three aspects to look at it. Number one, maybe we stress on the economic growth and the environmental protection, and also to make sure that we can contribute to the societal improvement. So these are the three qualities for sustainability. So when we're developing a product, and we have to consider the societal improvement and economic growth, and as well as the environmental, whether our products are environmental friendly. So thank you very much, Mr. Chen. Next, we would like to invite Dr. Lin from SC Group to give us your comments. First of all, I would like to thank our online participants. And the moderator also mentioned about for medical devices, it has long life cycle. Maybe the volume is not huge. However, when these devices are produced, and it is expected to have a long duration. And for us, because we are not be able to support that volume according to the volume we have. So for medical devices, the medical device molding companies, this is the issue. The quantity is the issue we have to face. And also the use of digital tools, of course, to track the safety. This is very important, especially for medical devices. So if we use digital tools to collect information and to track the problem and to clarify where the problem is, if we use these digital tools, and that these tools can help us to eliminate some of the source of the problems we have. And we have to really speed up the introduction of these digital tools, because if we can use these tools, we can have a good understanding of what is happening in the production process, and so that we can have corresponding strategies. And we need to cultivate the talents in this field as well. So in the medical device forming a device, we believe that there is still a lot of room for us to improve and to develop. And from our company, FSC Group, and we also provide training, and we provide the mass production technologies, and this is for the reference for our online participants. So for medical device injection molding, if you have any questions, and you are more than welcome to communicate and interact with Mr. Lin from FSC Group. And just like Dr. Lin said, that medical device in terms of mass production, it is a challenge, because for injection molding, and probably we have the in the past, our strength is the small volume or large variety production. But now in the production process, you have to have very flexible production process. So this is a new threshold for this industry. So thank you, Mr. Lin, for mentioning that. And it also has something to do with the digital transformation. And digital transformation is a way to tackle the issue of small volume, large variety production. So but we believe that for facility suppliers or processing vendors, and that we can try to do better in this regard. And the next question for Mr. Lee from Eternal, can you please use 2 minutes, very short time, to give your final comments? Thank you. The theme for this afternoon is the innovative applications in transportation and in medical field. Innovation, if it is only stayed at the laboratories without mass production, it has nothing to do with our lives. And if we have mass production, of course, we need to rely on the materials and the production process, and also the application. So these three aspects have to work hand in hand, so that we can have a really the innovation that has closely related to our lives. For example, in the Korea vehicle manufacturer, and 8 million, if their production capacity is 8 million, and the 1.6 million, it's probably not sold, and that is for the domestic market. And so for Korean vehicle industry, it has contributed greatly to the Korean economy.
By 2040, the Korean government hoped that their transportation innovation should be used in hydrogen-powered cars. So by 2040, they want to produce 6.2 million hydrogen-powered cars, and 2.9 million will be used in Korea, and the rest, 3.3 million, will be sold around the world. So I think that is a good example. That is to use innovation after mass production. They can really play a very important part in our economy. So for Eternal Materials, to innovate, we need to have mass production. So materials and design have to be combined together. So this kind of industrial alliance will speed up the improvement of the industry, so we can collaborate with all parties and create synergy and achieve innovation. So thank you to Mr. Lee. Deputy Director Lee mentioned a very important idea. In the morning, we also have the same concept, that is, we need to fight together. We need to create synergy. We need to find our partners, our suppliers from the upstream and downstream. We can all work together so that we can succeed. So whether used in transportation or medicine or in circular economy. So in order to make the product competitive, we need to have innovation in technology, and innovation in the processing technology. So these are the three pillars. All of them are indispensable. So when we're developing a new business opportunity, I think this is something we have to understand. We need to fight together. So thank you, Deputy Director Lee, for your important reminder. That is, we need to fight together. Finally, my question is directed to Mr. Wu from Henkel Taiwan. Please give us a quick summary. Thank you to our moderator. Thank you to our three panelists. I'm the sales representative of Henkel Taiwan. We are part of the German company, but I'm more than happy to join the Taiwan national team to fight together. I've been in this industry for over 20 years. We are one of the few companies that has a lab in Taiwan in manufacturing adhesives, so we can do some experiments. When we talk about the thermoplastics composites, actually, we are really scared of the thermoplastic composites because they are really difficult to be adhered together. For thermal setting products, we can do that happily, but for thermoplastic composites, that's really a big challenge. So I talk about the medical adhesives. We have a lot of Taiwanese customers due to confidentiality. It's impossible for them to take the materials outside of their companies, but based on our long-lasting experience, we can actually isolate our lab to ensure confidentiality of our customers. So when they're experimenting in our labs, we will not leak the parameters of their design. So I sincerely welcome our participants online. Please take full advantage of Henkel Taiwan's resources. Please use our Facebook platform. I really welcome the peers to join our Facebook community so that we can join the fight together. Thank you to Mr. Wu. Although you're working for a foreign company, but you will join the group fight with our Taiwanese counterparts. So once again, thank you to the four panelists. Thank you for sharing your insights. So from morning until now, we talk about circular economy, we talk about innovation in transportation and in medical devices. I have over 30 years of experience in plastics. So if you're going to innovate the industry, I think in terms of the change or the improvement of the technology, whatever we do, I think plastic and rubber always plays a very important part because no matter what kind of change is happening, they will always use plastics and rubber. So definitely we need to follow in the footsteps of the industry. We need to fight in a group. We need to work with the equipment, processing, materials. By integrating all parties together, we'll be able to develop the solutions suitable for the new challenges and new business opportunities. So once again, I would like to express my sincere appreciation to the four panelists. And I want to thank all of the participants online. Thank you for staying with us today. I would like to wish you all great success and prosperity. And may you all enjoy good health and prosperity. Thank you for your participation. I would like to hand over the microphone to the MC. Thank you to the moderator and the panelists for your insights. And thank you to all of the participants online. So we hope that we all have benefited tremendously. Our Plastics and Rubber Industry Trends Forum will now be concluded. May you all stay safe and healthy. Thank you.